real-time web applications are fairly ubiquitous now. Think about things like Uber, where you see the cars moving around on the map in real time, and even things like Facebook Messenger, where you're chatting and talking back and forth with your friends in real time. But how do you build a real-time web application? And more specifically, how do you build a real-time web application in .NET Core using WebSockets? Well, my friend, stick around and you'll find out. Well, hello, wherever you are, whenever you are, where am I? I always have to think about that. I'm in Melbourne, Australia. I can't believe I forgot that again. And when is it? It's July 2019. So it's been a while since I've made one of these videos, one of these tutorial videos. So I'm so happy, I'm so glad to be back doing it because I absolutely love doing it, and I'm really glad that you could join me for it. And I'm hoping that wherever you are, whenever you are, that you're happy and healthy and well, and it's great to have you with me. So as I said in the first introduction, this is a video about real-time web applications, specifically using WebSockets, and even more specifically through the lens of .NET Core and C#. Now, in this video, we're going to be doing two full step-by-step builds. We're going to build a client chat application where we can send messages in real time between multiple client endpoints with a server sitting in the middle. And we're going to do two builds. We're going to do, the first build is going to be a WebSocket build, .NET Core WebSocket server with JavaScript clients. And our second build is going to be a .NET Core server using SignalR. And we're going to have JavaScript clients using the SignalR library. And we'll come on to why you may want to do that a bit later in the video. So next, we're going to actually look at those apps that you're going to build, just so you can get a flavour of what you're going to end up with and how things are going to work. Before we do that, just one last mention. If you haven't already subscribed to the channel, please do so. Ding the little bell, and that way you'll get updates when I post new videos. If you don't want to do that, that's okay. I'm glad that you stopped by and watching the video anyway, but it would be nice to get another few subscribers. It just makes me feel so much better about life. Anyway, with that being said, let's now take a look at the applications you're going to build. Okay, so what we're looking at on screen here is our WebSocket chat application, and I've got three separate instances of the client app running, just so we can see messages going between the two of them. And in our background there, in the background, we have the WebSocket server, messaging server, just sitting there waiting to receive and send messages out. So let's connect our clients in. We'll connect all three. You can see they get back this connection ID from our server. That's something we have to build because WebSockets don't come with any kind of management layer, so we're going to have to build that as part of our build. And we're going to have to build our routing engine as well. So let's have a look at that now. So we're going to have two very simple routing rules. The first one is just a broadcast. So if we just type in a message, hello, and we click send, then we get a broadcast message out to all of the connected clients. You will see that in addition, the sending client will have this entry in its communication log. Now that's because we don't have any recipient IDs placed into the recipient box. Now this is a bit clunky. I was thinking about generating a drop down. I decided to leave it out because it would just make the tutorial too long. So instead we're going to have to manually cut the client ID from the client we want to send to, paste it in here. So we're going to send a message from this client to that client only. So we'll go hello again. And this time we'll see a message outbound here. We won't get an inbound message on client 2, and we should only really see an inbound server to client message on this client here. So we click send, indeed that's what we get, and poor old client 1 was left out of that messaging. So may seem quite simple, but there's a lot going on there. We're going to have to cover an awful lot to get that up and running. It actually surprised me, even though the WebSocket API itself is simple, and it is, to get this up and running on .NET Core, I actually found it quite challenging. There's a lot of work to do if you want to do it right, so we're going to do that. But before we move on to our build, let's take a look at the SignalR application. Okay, so we're over now in our SignalR version of exactly the same application, chat application. This time we're using SignalR. Prizes to those of you who can really see any discernible difference other than the word SignalR appearing on screen. The only one that really you will notice, if you're very keen-eyed, is the server connection URL is slightly different. And all will become clear. Otherwise, everything works in pretty much exactly the same way. We connect in, we get back an ID, and then we can send broadcast messages, or we can send targeted messages to other clients. I'll just show you that, just to show you that it's all working. Oh, we didn't copy the full string, that's why. Let's just do that, just to show you. Okay, there we go. So the reason I made the clients, or the applications generally, so similar is so that you can actually compare and contrast both the build process and how they fit together very, very well. You can compare them very closely because they're doing basically exactly the same thing. And you may then choose to take one approach over the other. Now, I'm not going to preempt that. I have my own personal views on it that will be revealed later. So having had a look at the apps you're going to build, before we actually jump into building them, let's do a little bit of theory. There's not that much, just to level set the playing field and get us all starting from the same point before we launch into the build process. So let's go and do that now. Okay, so yes, this is a step-by-step into WebSockets versus SignalR in .NET Core. And again, as usual, we will do full step-by-step examples in both those technologies, WebSockets and SignalR. So if you're not here for that, you're in the wrong place, but stick around, you might learn something, you might even enjoy it, who knows. So what you'll learn when done, you'll understand about synchronous versus asynchronous principles, just generally, and also specifically with regards C# programming, because it's a theme that recurs a lot throughout the tutorial, and it's something you have to understand, so we'll cover that, which may be a surprise. We'll go over HTTP, XML, HTTP request and WebSockets, just as a bit of a background to what WebSockets are and why they exist. We'll take a very brief look at the WebSocket API. It's pretty simple. And then the main part of the tutorial is we'll do a full WebSocket server in .NET Core, and also we'll have a JavaScript client. And then we'll also cover what is SignalR, and we'll build a full server application in SignalR with another JavaScript client as well. So what you'll need, text editor, I use VS Code. I recommend you use it, it's really good and it's free. .NET Core SDK, again free. Web browser, if you don't have a web browser you're going to be really stuck. And I've put about 60 minutes of your time, you might need a bit more than that. And it would be advantageous to have some JavaScript programming. You don't need it, but it would be, if you know JavaScript, it might just flow a bit easier for you, but we do cover everything that you need to know in this tutorial, so don't worry if you've never done JavaScript. Okay, so just a brief bit of theory about HTTP, XML, HTTP requests and WebSockets. Now that one in the middle, XML, HTTP request, I might start referring to it either as XHR, which is correct, or even AJAX. So if you've done any JavaScript programming and you know what AJAX is, XML HTTP request is sort of part of AJAX. So it's not technically correct to say that that is of itself AJAX, it's not, but it's almost sort of synonymous. So firstly, HTTP, it's been around a long time, since the 80s I believe. It's based on a request response cycle, so if you've looked at any of my other videos on REST APIs, it's, you know, the examples I've done anyway have been based around HTTP and the get and the post verbs of HTTP. So it's still very much alive and well. It's not a legacy protocol by any means, and it's the foundation really of the internet. It's synchronous, so starting our concepts or discussion on synchronous versus asynchronous. When we say it's synchronous, we mean it's just you request something, you get result back. You request something, you get result back. So you basically wait for the work to finish before you get your result back. It's almost like a serial approach, okay? It's stateless. So again, this is one of the powers of it. It scales really well. You can have thousands, millions of connections to a server, literally. And it makes a request, gets the result back, and then as far as the server is concerned, that's your interaction done. It doesn't maintain any type of connection or state. Here's a quick diagram on HTTP. So as we said, we make a request, the server does all the work that it needs to do, and then it responds back, and then the delta in between the request and response is kind of the wait time, if you like. And in the early days of the internet, that would most usually manifest itself as you've got a page, you submit a form, and another page loads as a result. Single page applications where stuff happened just within the one page were quite rare. In fact, they didn't really exist. And so you were on one page, you went to the next page, and the delta in between that page, the second page loading, is kind of your wait time, which is bound by a number of factors that you generally don't have control of: the endpoint server, the network connection, all that kind of stuff, which is relevant when we come on to talk about asynchronous messaging and method calls. And then the request response cycle just begins again, and there is I've got two request response cycles on the screen there. There is no linkage between the first set of request response and the second set of request response. They are totally independent, and that's why it scales really well. XML HTTP request, as I put there, underpins AJAX. First debuted in Internet Explorer 5. I thought I'd put that in because it's quite interesting. I don't know why, it just interests me. And it allowed for partial UI updates. So still request response, but it allowed you to do things like look up an address on a web page, and there would be some activity in the back end, asynchronous activity, that would pull back a result set. So basically allowed you to do single page applications, partial UI updates, and it just made the web a much more usable platform. Can be asynchronous, so you can, again, I've got an example here. Here's a picture from the Australia Post website, and I'm sure you're all familiar with something very similar. You start typing something in and you get a result set back. Google does it as well when you start searching, and I'm fairly sure there's some kind of asynchronous process going on there. And so it means that the result sets gets whittled down. Your typing into the text box is not delayed, so you don't type in one character, wait for a request response cycle, and then you're able to type another character. I have used applications that have behaved like that. I'm sure you have as well. But the whole asynchronous nature of AJAX means that you're not constrained. You don't have to wait for the result to come back, and you can keep typing, and the result sets gets whittled down to something more appropriate. And I've also put in there XML HTTP request can be used in something called long polling. Now, long polling is almost an alternative, it's not almost, it is an alternative to WebSockets, but with long polling, you'll make a request, and as the name suggests, you will wait a long time, as long as you need, or as long as the server needs to return a bit of data back, and it gives the impression of kind of real-time updating, and it's less chatty than short polling. Short polling is basically just, have you got a result? Have you got a result? Have you got a result? Even if there is no result available. So long polling only returns a result when there is one, and that can take a long time. And I believe Facebook actually use long polling in their chat application, which is quite interesting. So we're not going to really delve into that technically today, but I just wanted to give you the background to what XML HTTP request is and why it exists and what kind of features and functionality it gives us. Finally, we move on to the main event, WebSockets. So actually, WebSocket connections start with a HTTP request to upgrade the connection to a WebSocket connection. It's bidirectional, which is not any massive surprise. But one of the main points of difference with the other things is it's persistent or nailed up. You actually have an established connection between the client and the server that stays there. It's like an open connection. And either the client or the server can send messages in a bi-directional fashion at any time. It's not waiting for somebody to do a request and then hit back a response. clients can just send data in both directions at any point in time. It's really the closest thing you're going to get to an actual network port or connection in a browser. And here's a quick schematic here. So the client will make a request. It is a HTTP request to upgrade. If we are able to sustain a WebSocket connection, because not every environment can, then if we are able to, then we get a response handshake back going, yep, that's all cool, let's have a WebSocket session. And then you just have this one full duplex, fully persistent connection with the client and server can send things back and forth. So ideal for real-time applications. Just a bit about the WebSocket API. There's only really two methods, send and close. Fairly self-explanatory, so sending messages and close down the connection. We have 4 events, so we'll get an event when the connection is opened, we get an event when there's a message, I won't go on, an event when there's an error, an event, well, I have just gone on, an event when it closes down. Now, the WebSocket protocol is defined in RFC 6455. I've put links down in the description below, or of course on the blog as well. The protocol, from my perspective, is defining more the kind of networking type of stuff, which I'm not terribly interested in. And then you also have the WebSocket API definition, which is defined by the W3C, which is probably more what we are interested in. I'll be honest with you, the W3C documentation I think is absolutely dreadful. It does the job, it's just not very readable. So, of course, as part of this tutorial, we will use Microsoft's implementation of the WebSocket class, and we'll also use a JavaScript implementation of it as well, they're both basically circle around the main API definition, but there are some slight differences, especially in the Microsoft space. Surprise, surprise, but nothing too dramatic. A bit about our application architecture. For our WebSocket app, we have our HTML and JavaScript client on the left here. I've made the conscious decision just to use HTML and JavaScript. I'm not using anything like jQuery, which is a JavaScript library. I'm not using anything like Bootstrap to provide nice UI elements. The web app looks like something out of the 1990s, which I personally quite like. And it just keeps things really focused and really simple in what we're interested in, which is, of course, is WebSockets. Then on the .NET Core side, we have a server application. We're going to be writing 3 custom classes from memory, which are shown there in green. So a WebSocket server middleware class, which is going to contain the stuff that we need to establish connections and even do some routing. We'll need to write a manager class. I'll come on to why we need that in a bit. I don't want to ruin it now. And there's another class that's important, clearly very important, but I've not put it on there, and we'll cover that when we come to doing the build. And of course, program and startup classes. We'll be doing a bit of work in the startup class. And a central element of this tutorial will be around the .NET Core request pipeline. We focus quite heavily in on that because it's really important. Other than that, relatively simple architecture. Now, just before we go on to the build, we've got 2 builds. Just to remind you, we've got a WebSocket build and we've got a SignalR build at the end. Insofar as our WebSocket build is concerned, I've broken it down into 5 phases, so it's not all one big dump of information. So I'll take you through those first, and then we'll come on to doing our first phase build of our WebSocket client. So the build phases are get connected, so in that we set up both projects, our server project and our client project, and we actually write enough code to establish a WebSocket connection. So straight off the bat, you're going to learn how to do that. We're then in build phase 2, we're going to actually send and receive messages. So phase 1, we're just connecting. Send 2, we're going to send and receive messages. So we could potentially even leave it there, but I will not leave it there for various good reasons. Part 3, we're going to upgrade the middleware. So this is really around our discussion on the internal architecture of the application and making it adhere to kind of some decent standards. In section 4, we're going to add our manager class, and that is needed, and I won't ruin the surprise, but it's necessary to add a management layer. WebSockets, as you've seen, are very simple. It doesn't really provide that much other than this connection, and so adding a manager class is required to manage our connections from within our application. And then finally, we're going to add a router. So it's a bit of a grandiose term for what we're actually going to do, but again, you will see we will have effectively at this point number 4, build phase 4, we're just going to have, we could potentially have multiple clients connecting in, but they're all effectively independent connections. One client cannot send a message to another client. So we need to add this routing functionality on our server so we can start routing messages between clients, which is really the entire point of a chat application, which is what we're building. So step 5 is absolutely necessary. So with that, that's our introduction and what you're going to learn done. I think we now move on to build phase 1 of our WebSocket application. Alright, so we're going to get started on build phase 1, which we call get connected. And in this section, we're going to set up basic functionality in our client. And also we're going to start building our WebSocket server. So we're going to effectively build everything required to connect the client to the server via a WebSocket. So let's get started with that. So the first thing we want to do is go to our workspace on our wherever you're choosing to create your projects. I'm going to create mine on this external drive here, and the first thing we're going to create is our WebSocket server, our WebSocket client project. So we just create a folder called WebSocket Client. And this is literally just going to have one HTML page in here that includes our very simple HTML and JavaScript. So I'm going to use VS Code to do all the coding. So we'll just open VS Code as usual, and then we'll just open that folder. So we have a workspace, and then we'll just add a file. And we'll call it, you can call it anything you like. Call it WebSocket Client HTML. And now basically I'm just going to start with the HTML code, which will take a while to type in. I don't want to cut and paste it. I want to kind of type it in step by step. So when I get to this point in the editing, I'll speed up the coding aspect. Once I've finished the HTML, I'll quickly take you through that. And then we'll move on to the JavaScript. Okay, so that was fairly torturous, but I sped it up for you so you wouldn't have had to have watched me type it in real time, which would have been very torturous for you. The HTML is pretty simple, so if you were watching along with that, nothing in here should be too difficult to understand. So let's save it and we'll actually have a look at the file or the page that you get as a result of the code. So if we go into our project, let me just open this in Firefox. And I drag this over here. This is basically the page that we get. We have a connection status, we have our connection ID, which, well, we don't have one at the moment. We have a input box for our WebSocket server URL, which we'll code that up in a bit, a connect button, and you can see here the other user interface elements are disabled because it makes no sense to try and close a socket when we don't have one open. And then we have a communication log, which is basically just going to log all our requests, both to and from the client. Probably the only thing really worth mentioning, and we'll come on to this next, is the IDs that we've given some of the HTML elements. We make use of these IDs in the JavaScript to change the HTML text, for example, of the status. So it's fairly simple, straightforward stuff. So why don't we go on and complete the client, well, this stage of the client, stage 1 of the client, by putting in the JavaScript. So we'll do that now. Okay, so you'll be pleased to hear that was the longest section of typing in the whole tutorial, so you won't have to watch anything like that again. Let me know if you think that's too much and if you'd rather I just cut and pasted code in. I try and avoid doing that because I feel it's not really, I don't know, it's a bit unfair and it's like I'm taking a shortcut. So if you would rather I did that, then fine, but to be honest with you, if I did that, I wouldn't really see the point in doing a tutorial then. I think the value is in seeing me make mistakes, because I'm sure I've made some, and then going back and correcting them. So that's kind of hopefully the value that these tutorials bring. So anyway, there may be some mistakes in the code, there may not, but we'll find out as we move through the rest of the tutorial, and we'll just fix them up as we find them. That's fine, that's what you do as a developer. So let's actually open up our file, our page, and see how it's behaving. If I can find, here we are. So again, I just use Firefox, it's my preferred browser. I would recommend either Firefox or Chrome. Edge, for me, has still a few weird behaviors that I can't be bothered to deal with. Anyway, the first thing I would do if you're doing any JavaScript programming is open up the Web Developer Tools and open up the Web Console, just to make sure there are no JavaScript syntax errors, and that looks okay. We'll just do a page refresh, and that's all looking clean. The first thing you'll notice is we actually have a URL in our WebSocket server URL text box, and that is populated through our JavaScript. We'll step through the JavaScript in a bit. Let's just see what happens if we try and connect. So we get an error in our console saying we can't establish a connection, which is fine, that's what you'd expect because there's nothing there at the moment. And then we get our connection state updated to this WebSocket state 0, which doesn't look too great. So let's go back to our code and we'll try and understand what's going on there. It's fairly straightforward, to be honest with you. There's not too much to mystify you, I don't think. So the first section is just setting up all these JavaScript objects that we use in our subsequent functions, and it enables us to update their state, whether they are disabled or enabled, and also change the values of the HTML. So we can change the state labeling. So just before we move through the events, let's just jump down to these two support functions that we call throughout the other functions. The first one's escape HTML, which takes a string and it basically just replaces any literal strings with the HTML safe equivalent. And then we've got this update state function. We'll not step through it because it's quite long, but all it does really is enable and disable the buttons depending on the state of the WebSocket connection. And it will update things, for example, the state label. So for example, when we got that last error, it would have been this default case that would have run, and it would have updated the state label with this information here. Okay. So jumping back up, the first and only event we have wired up on our client is on the connect button, on the onClick event. Again, I've made a conscious decision not to use anything like jQuery. We're just using pure JavaScript just to keep it clean. We will update the state label to say we're attempting to connect. Most interesting thing really we're doing is creating this WebSocket object and passing in the connection URL. Assuming we can open the socket, then we update our state, and we also update the comms log with our connection opened event as well. Same with our onClose, very similar. We update our state and update our comms log. If we get an error, then we'll update our state with whatever that is, and that you've seen that already running. And then if we get a message on our WebSocket, we will display that in the comms log, and obviously we're not getting any messages as yet. So fairly straightforward. To really see if it's working properly, we will now create our server code next. Let's jump over to our desktop again, and we'll just kill our, well actually let's just close our client project. Let's just close the folder. And if you bring up a new terminal, and I'll move over to my F drive, which is where I'm storing my projects, and we'll create a new .NET project. So we're going to use the web template, which is the most basic web-based template they have. So it sets up some of the stuff that we need for us, but it's fairly basic. And we'll call it something like WebSocket server. If I could spell correctly, that would be even better. Okay, cool. And then we'll just open that in Visual Studio Code, open folder, and we'll open up a WebSocket server. And there we've got our empty project. We're really only concerned with the startup class. Let's just click yes to this. As we're doing all our work in here for this section, I won't take you through the rest of the anatomy of a .NET Core web project. If you're interested, there's an article on my blog which explains that particular information if you're interested in it. I think it's the one on Azure DevOps. So if you want to understand the anatomy of a .NET Core project, read that article. It takes you through it. There's also a video on YouTube as well that you can watch that takes you through it. But we'll explain it as we go through, so you're not going to really miss out anything anyway. So startup class is basically, surprise, surprise, where our startup code runs to begin with. And we have two main methods: configure services, where we add services, surprise, surprise, that we want to be able to run and make available throughout the rest of the application using something called dependency injection. We'll cover that briefly later. And then our configure method, which is really responsible for setting up a request pipeline. We talk a lot about the request pipeline in this tutorial, but we'll build up that as we move through the rest of the tutorial. So let's just take this stuff out. It's not really that important. And we're going to do all our coding in here. But first, what we want to do is add a using directive at the top and add our wrong namespace, system, net, WebSockets. And the first thing we want to do is add WebSockets to our pipeline. So we do that by app.use WebSockets. And again, I will take you through what the request pipeline is and more specifically what request delegates are. I'll tell you briefly what they are now. Request delegates are items that you can add to a number of request delegates actually make up your request pipeline. So you can add multiple things to your pipeline that will intercept and deal with the request and perform some logic on it or not. So by adding WebSockets to our pipeline, we're giving it that capability. What we're going to do now is basically add our own request delegate that's going to allow us to connect that WebSocket. We do that with the app.use syntax, and then there's a standard signature for a using request delegate, and there's three types of request delegate. I'll take you through what they are, but we're going to create a use request delegate. And that requires a context, if I can spell it correctly, context object and a next object. And we will use this context and this next object in this request delegate. So the first thing we want to check is we want to check the context. So it's basically checking what is the context of this request pipeline. And the first thing we're going to check if it is a WebSocket request. So you'll remember from our overview of WebSockets that it actually starts with a HTTP request to upgrade the connection to a WebSocket. So that's what this is here. It's actually checking to see if we have a WebSocket connection request. If so, then we'll do something. Before we deal with that, if it's not, then all we do is we await the next request delegate. And again, I've got a slide that explains this, but basically we can, as I said, we can have multiple request delegates in a chain. And so what we're saying here is if it's not a WebSocket request, then just go to the next request delegate in the request pipeline. As it stands, we don't have one yet, but we'll play around with that in a bit. So that's all that's doing. If on the other hand we actually do have a WebSocket request, then this is where we want to actually do something. I'll also come on to async and await later, and I've got a section on asynchronous programming in this talk. It's actually really important when we're talking about things like WebSockets that you know what async and await are, and you'll see it used in the code we're going to write here, but I do explain what that is later as well. It's effectively how we do asynchronous programming, or how we can do asynchronous programming in .NET or in C#. So if we do have a WebSocket connection request, then we create a WebSocket object, assuming I can type it correctly, and we'll call it something like WebSocket. And again, we're going to use this await modifier here, and we're going to wait. Not doing that one. I'm going to accept the WebSocket connection. And we'll do a console write line just to see that it has in fact connected. So again, just to take you through what's happening, we're checking to see, we're looking on our context object, we're checking to see if it's a WebSocket request. If so, we create a WebSocket object, and we use this asynchronous pattern here that's repeated throughout this tutorial, where we await, which is basically saying, okay, we know that something's going to take a while, possibly, to connect. So let's await it. I'll take you through what actually happens when we await something. But park that for the moment, so we await on this method here basically, and again you can see it's an asynchronous method, so it may take some time to return, and it's basically just saying, yep, we're going to establish the WebSocket connection and upgrade to a WebSocket session, and if we are successful, then we will then write that out to our console log. Let me just put a semicolon in there, and I think we will be good to go. So let's save this. Okay, so that's the end of our server build for this section. So let's see if it runs okay, and let's see if our JavaScript client can connect in. So back over in our project, let's open up a terminal window, and we'll build it first of all to make sure it's building. So .NET build, 0 errors and 0 warnings, that's good, and then .NET run. And you can see here it started on localhost port 5000 if we're using HTTP, and 5001 for HTTPS, and that's configured in launch settings JSON here if you're interested in that. So that looks like that's running okay. Let's move back over to our client, and we'll open that up, unless we have an instance running. No, we don't, and we'll run that in Firefox. And again, it's always useful to open up the developer tools, web console, just to... It's getting a bit crowded because I'm running at a lower resolution, well, magnified the resolution at 150%, so you can see things more clearly, but we're getting a bit crowded. Nonetheless, let's see if we can connect in. Well, let's see if we can connect in. Cool. So we've got connection opened, we've got no errors down here, but I was expecting something else to happen here, and I think there might be an issue with our client. So let's open up our client project, just because I'm expecting something to happen there that didn't happen. Okay. So we called this socket open. Well, this socket open event occurred because we opened our socket. I was actually expecting to get a close event as well, and I was wondering why we didn't, and I'm realizing now because we've got an error here. So it should be that. So this was not firing because I was expecting it to fire. So let's save that. Let's reload this. Okay, so let's try again. Yeah, that's better. Okay, so we do get a connection, so the connection is opened. and you see that it was opened down on our server here, WebSocket connected, that's cool. But we then almost immediately get a connection closed event as well with this 106 reason code, which from memory is something like it's a kind of illegal termination of a connection or something like that. Can't quite remember what it is. But it's not good, basically. And the reason that's happening is because our WebSocket object is quickly going out of scope. So we did create it, but then almost immediately it just gets closed or it dies because we're not persisting it, we're not keeping it open. So that's what we'll do next. Okay, so we've done some code, and whether you realise it or not, I think I have mentioned that you've created your first piece of middleware in the request pipeline, but I wanted to delve into that just a wee bit now, just from a theoretical perspective, because it's something I feel you really need to understand. We could gloss over it. I think if we did that, you wouldn't understand WebSockets quite as well. So what is the request pipeline? Well, on screen here, this diagram is lifted directly from Microsoft. The request pipeline basically comprises multiple pieces of what we call middleware. And we'll jump back over to the code actually. What we've written in our code, this is a piece of middleware, as is this, okay? And so everything configured within here is basically our request pipeline, okay? So there's a request pipeline, there's multiple bits of middleware. A request comes in and it propagates its way through the middleware and returns back, theoretically. So comprised of multiple middleware components. They decide how requests will be handled. We build middleware with request delegates. So again, that piece of code I showed you, that is a request delegate. And we can have three different types. Run, and they run at the end of the pipeline. You would put a run request delegate at the end. Map is used to branch the pipeline, and use can short circuit the pipeline. So we've created a use request delegate again. Let's just pop back over. This is what we say here. So you can either have app use, app run, app map. We've got an app use. And let's go through this example again on the slide just to show you exactly what is happening. So skip through that. Okay, so this is what we've coded. So we've added two bits of middleware. Here we've got app use WebSockets, which is an out-the-box request delegate you get with WebSockets. And then we've created our own request delegate, app use, context, and next. So what happens is a request comes in, some logic is performed here. We then come into our custom request delegate and we determine if it's a WebSocket request. If it is, then we do what we do in the code. We await a connection and then we return back through the request pipeline. So when we say short circuiting, this piece of custom middleware or request delegate has short circuited the pipeline and returns us back through it. If it isn't a WebSocket request, then we come into the else statement and we await the next request delegate in the pipeline. And it just so happens, I've just put the arrow coming in and back out again, there isn't one. And then we just come back through the pipeline. So you have logic before and logic after you propagate through the pipeline, and then you get your response. So the idea is you build up actions on your request. And Microsoft actually recommends that you add middleware in a certain particular sequence depending on what kind of thing they do. So I've put links to that in the description below and also on the blog, which will take you through their recommendations there. So what we're going to do now, just to illustrate this point, is we're going to add another custom request delegate, a third one, at the end of our pipeline, and you'll see how that behaves. Now all it's going to do is just print something to the screen. It's not going to do anything valid. It's just to help you understand request pipelines. So we're going to come on it and we're going to do that now. So the first thing we're going to do is add a third request delegate into our configure method after the two request delegates we already have. So we're going to do app run this time. Now just going back to our slide where you'll remember that we can have three types of delegates, and any request delegate that uses run, this runs at the end of the pipeline. So what we're really saying here is we expect to be the last delegate in our pipeline, which makes sense. use the async keyword as well because it's an asynchronous operation, and we pass in the context before, which is just the request context. You'll notice we're not passing in this next task because it's the last delegate in the pipeline. We don't need to pass on that or await on that as we did with the other ones. Okay, which kind of makes sense. So let's just write up our code, and it's fairly simple. We're only going to do two things in here. The first thing we're going to do is just write out to our server console, just so we can see what's going on. We'll just say hello from the third request delegate. And then we're going to actually add something to our response. So we access that via our context and find our response, and then we're going to perform a write, and you'll notice it's write async. So again, it's an asynchronous write, and we'll come on in the next section to talk about asynchronous programming. For now, just bear with me, and we'll just copy this. So just copy this text into here. Now, you might be a bit confused between these two things. This one here is really just writing out to our, put the semicolon in the wrong place. This one here is just writing out to our server console. This one here is actually writing this string to our response via the request pipeline. You'll see how that works in a bit. And then all we're going to do in here is we're going to do another console. Actually, let's just let's copy this one. Doing exactly the same thing, but we'll just update the text from the second request delegate. So again, here's our first request delegate that will run. We then come on to our second request delegate that we wrote in the last section. If it's a WebSocket request, then we do something and we basically short circuit the request pipeline. Otherwise, I guess we assume it's a HTTP request, and we write this out to the console, and then we call our next request delegate in our pipeline, which is just basically going to do this stuff here. So let's test that now. So let's make sure we save it, and let's run. So again, as before, we'll just try a WebSocket connection. That's all working. We get the connection opened and then it immediately closes. We'll deal with that later, and we get the WebSocket connected message. That's fine. That's what we expect. You'll notice this doesn't run and this doesn't appear to run either, which is correct. So let's get these elements to run. And this is just showing you how the request pipeline can operate in different ways depending on what's been passed into it. So let's open up another tab, and we will go to our local host on port 5000. So this is not a WebSocket request, it's just a regular HTTP request. We hit return. We get this hello from the third request delegate, which is this line here. And then if you look down at our console, you can see this was triggered, and of course this was also triggered. So that's just demonstrating how the pipeline can change depending on the request type. So just to illustrate that, we pop back over to our slideware, and I've got a final slide on this. Here we are, here's a request delegate. So a request comes in, the next method gets called in the first one. If, again, it's repeating what we've seen before, if it's a WebSocket request, then we short circuit the request pipeline and return. If it's not, then we await the next delegate where we have done our write line stuff and blah, blah, blah. You've seen that in the previous example, and it will return back through the pipeline. And yeah, you've seen how that works via our example. So we'll leave the request pipeline there for now. I think that's enough detail to help you understand how that is working, and it's a very important concept. And again, the thing to take away is that is all set up within the configure method of the startup class. All right, now just before, we've got a couple of things to finish off in this build section. It's probably the longest build section in the video, so I'm just going to cover off what the request headers look like at the server end. So we've talked a bit about this concept of a HTTP request being upgraded to a WebSocket. I just want to show you what that looks like in the server. And to do that, we're going to write a little custom method. It's quite simple, just to print out the request headers basically. So if we pop back over to our application, we're going to write that up now. It's fairly straightforward. So we'll go public void write request param, and we're going to basically pass in a HTTP context, and we'll call it context. Cool. So basically the same thing we've been using up here. We're just going to pass that in, and we're going to print out various properties of that HTTP context. So we'll print out configure console write line. We'll print out two of the main attributes before we print the headers. So request method, and we simply access it by context request method. Don't know what happened there. Okay, and let's just copy this, and we'll also write out the protocol. So you can see what's happening there. Cool. And then we'll just print out the headers. So in order to do that, we'll just check that our headers object is not null. It shouldn't be. It's worth checking anyway. So assuming they're not null, let's loop round them. So for each var h in context request headers, we'll just print them to the screen. So console write line, and we'll just indent them, and we'll put h key, accessing the key attribute, and then the value. So they're basically key value pairs. H value. Save that, and let's not forget to call this from, we'll call it from our second request delegate, just to see what's getting passed in at this point, request param, and we're just passing over the context. Quite simple. Okay. Now you don't need to do this again, this is just to hopefully extend your learning. We've saved that, so we'll do a .NET run. And let's just refresh this. And let's connect on our WebSocket. So you can see here we've made a WebSocket request. Our method was get, our request protocol was HTTP. You can see there's a lot of other things down here. You can see there's this upgrade key to WebSocket request. And there's also, I'm sure, yes, here in this connection, we've also got an upgrade request here, along with some other stuff. The only other thing I'll just get you to pay your attention to is this origin key here and the value of null. Now what the origin is, because this is important a bit later on, is where this client is running. So if this was actually running on a web server, it's not, we're just opening it as a file. In the origin you would see HTTP, you know, google.com or whatever. Here, because we're running off a file, the value is null. So just park that for now. It comes back a bit later when we talk about SignalR, and we'll circle back to this as well, this conversation here. That's it for this section. It was really just to show you the nature of the upgrade request and the HTTP headers and how we establish a WebSocket connection. So next, we're going to just do a bit of an overview of asynchronous programming in .NET, because the next section of code we're going to write, relies fairly heavily on it, so you should really understand how it's working. So let's do that now. Okay, so we move on to a bit of an overview on asynchronous programming in .NET. Now, it's a pretty large subject area, and I don't want to go into massive amounts of detail because it might derail us a bit too much from the main point of our talk here, which is WebSockets, but I felt it was necessary just to provide a one-pager on what asynchronous programming is, because it does feature quite a lot in our video. So you really need to understand what it is. So if you do understand it, this section won't take too long. If you don't understand it, hopefully this will start to help crystallize what asynchronous programming is. But what I'd also recommend is that you pop over to the associated blog article, and I've got a link in the description below. And there's two articles that you really should read if you've not done this before. And one is about the asynchronous task programming model. So it's more about the theory. So I've got an overview here that goes into a bit more detail. And then there's also a really good article on the flow of control through asynchronous code, because it can get a bit confusing because you kind of jump around from place to place, but there's a really good example with a worked example that you can follow through, and it will help you out if you've not done this before. But anyway, back to our overview slide. Asynchronous methods use the async modifier, so you'll notice when you define an asynchronous method, you will use async as one of the modifiers. Asynchronous methods will usually return a task. Tasks represent ongoing work and will eventually return with either the result or an exception. So as we said before, with asynchronous methods, generally, you expect them to take some time to complete. So it's usually long-running methods, like stuff over a network where you really have no control of it, and you expect that it may take some time. So what you would typically do is you'd kick off the method, you'd call the method, and you would await for it, and we'll come on to a bit what I mean by that. You'll wait for it to return at some point in the future. In the meantime, you can potentially get on with other work. Sometimes you can't, but sometimes you can. And most usually, or a lot of the time, it's used to stop the user interface from being blocked. So even if you're doing something and you're awaiting something, the user interface is still responsive. So it's often used for that, but also you can kick off other processes at the same time. Now at some point you may need to bring everything together at one point before you can continue on, but that's getting a bit more detailed. We don't really need to do that here, but we are using asynchronous methods, so it's useful that you understand how they work. So yes, a task is the thing that you will await on when you call an asynchronous method. So just a bit about naming conventions. Asynchronous methods will usually end with async, so that gives you a clue as to the fact that they are asynchronous methods. And then await statements can be used to basically call those asynchronous methods when you need them, and what they really represent are suspension points. So basically, we're going to call an asynchronous method. We use the await keyword to call it, and basically what that's saying is we cannot continue past this point until we get the awaited process complete, until the task is returned back to us. So when you talk about asynchronous programming in .NET, you'll often hear await, async, await is a pair of keywords that you'll use, and that's basically what they are. Async is the modifier on the actual method, and await is the keyword that you use to call that method and await for a result. Basically it. And while we're awaiting, the control returns to the async method. So while we've kicked off a process and gone, okay, I'm going to wait for this to come back, the control returns back up the chain to the method that called the async process. And potentially you can continue on with something else if that is the case. So that's basically asynchronous programming in a nutshell. And that actually brings us to the end of our build phase 1, where we did quite a lot of work and we covered a lot of theory. You'll be pleased to hear the subsequent build sections, build phase 2, where we send and receive messages. It's less theory, more coding, where we start to embed the concepts that we've gone through. Okay, so build phase 2, it's a lot shorter than the first build phase, where we actually crammed a lot of stuff in, and we're going to work on both our client app and our server app, basically to allow for the sending of messages. So let's not wait any longer, let's delve straight into it. So that's our server app, so let's kill that, and let's open up our client app. And let me just maximize this. So this will be familiar to you. I'm not going to obviously go through the code again. So the first thing we're going to add is an event onto our close button. So we've got our connect button on click event. We're going to add one for our close button. Close button on click. And again, be running a function on that. And basically we're going to do a quick check on our socket object, if I can spell it correctly. So first I'm going to say if we don't have a socket, or, and the syntax, interestingly, is very can be very similar to C#, so it shouldn't be too alien to you. Or the socket ready state is not equivalent to web socket open. So basically, if you don't have a WebSocket or it's not open, then we're just going to fire out an alert, which is basically a box that can tell us something. We could write it to the console, but I think we probably need to write it out to the user. Socket not connected. So because we're augmenting our UI using the update, whatever it's called, here it's here, the update state method, we shouldn't get this, but you never know. It's worth just checking anyway. Assuming it is okay, then on our socket we're going to call close. And with a method code of 1000 closing from client. And basically that 1000 code is basically saying it's a clean closure request from our client. Everything's fine. And then we are going to, the only other thing we're going to do is on our send button, again, wire up an on click method to send a message. And we again declare a function. And we're going to do a very similar check if we don't have a socket or the socket ready state is not equivalent to web socket open. Then again, we're going to write out, I should have just cut and paste that, shouldn't I? Realizing it's exactly the same code. Let's just do that then. Saves you watching me typing. Okay, cool. However, assuming we do have an open connection, we want to then send a message. So we're going to declare an object called data, or a variable called data. And that's going to be equal to the send message text box, whatever we have in that, the value of that. And then we're simply going to, on our socket, call the send method. Now you'll remember from our WebSocket API there was two methods, send and, what was it? Send and open? Let's just have a quick check. Yeah, send and close, okay. So we're going to send some data over our WebSocket, and what we're going to send is going to send this data variable, fairly straightforward. And then we're going to update our communications log. So I think I can probably, yeah, let's copy this code here. I think that will be sufficient. I might just have to edit it. Okay. We won't use event data because we're not operating off event. We're just going to pass in this data. So we're just escaping the data and we'll update our comms log. And that's it. That's our client. Fairly straightforward. So wired up our close button to issue a close method call, passing it a nice clean code of 1000. And we're also wiring up our send message button and passing in the data that's in our send message text box, and we're just escaping the HTML data. So that all looks good. Let's move on to our server now. All right, so we're going to move on to our server component, and we're going to write a asynchronous method to receive any messages on our WebSocket, and it's also going to resolve the immediate closure of our WebSocket, because we effectively go into not an infinite loop, but a while loop that just exists under the condition of the WebSocket being open. So while the WebSocket is open, we're going to be in this while loop. Because it's an asynchronous method, we can pass control back to other parts of the application, so we're not blocking it. It's arguably, well, it's not arguably, it is the most complex, difficult to understand bit of code we have in our application. I will just show you again. I'll try and explain it as best I can in the video, but I do have full code, the full code in the blog, and also with full explanations of what is going on in this method that we're going to write, this receive message method. It's quite tricky to understand, but I explain it in full here. And then just following on from that, I actually go through the asynchronous method calls and what actually happens at each stage, because it's quite tricky, but there's no way of getting around it. It is what it is. So we'll go through it here in the video, but just be warned, it's quite tricky. So back over in our server code, just make sure you add this using directive that wasn't there previously, using system threading, and now we're going to write up our receive method, our asynchronous receive method. So private, it's asynchronous, so asynchronous modifier, it's going to return a task, and we'll call it receive message. And it's going to expect two things. It's going to expect a WebSocket, call it socket, and then the next thing it's going to require is something called an action delegate. And an action delegate is almost, well, it's not almost, it is, it's a method that you can pass to into a method, and it can also pass stuff back out. So declared with this action keyword, action delegate, and again in the blog I've put a link to what action delegates are and explain a bit more about it. And we're going to expect a WebSocket. Compare WebSocket receive result, along with a byte array, which is our message. Okay, and we'll call it. So let me write the rest of the code before I try to explain it, because as it is, that will probably make absolutely no sense to you. So let me write the rest of the code, and then we'll step through it, and hopefully it will make a bit more sense when we do that. So within our receive message, we're going to, now just an interesting point of note, you can see that we've declared our asynchronous function, and we're getting this complaining message here. And if you have a look at what that is, it's saying this async method lacks await operators and will run synchronously. Okay, so within our async method, we expect an await operator. So it's not going to stop it compiling, but it's just saying, you've said this is an asynchronous method, and it's not asynchronous, basically, and it'll run synchronously. So within it, we're going to declare a buffer, and this is how we are going to get the message within our WebSocket. And it's just a byte array, basically. And again, this kind of talks to maybe the WebSocket protocol. We'll have further information on why we declare it in this way. But for the moment, we have a byte array that will contain our message string. And then, as I say, we need to enter into this while loop, while this socket state is equivalent to WebSocket open. Okay, so while the WebSocket is open, that we've passed in here, we're just going to keep looping round. Okay. Okay, so within our while loop, we're going to expect a result back from an asynchronous method defined by Microsoft on the socket object. So they have these two methods, receive async, where we receive messages on the socket, and send async, we're going to use receive async. And then looking at the method signature, basically references the application buffer. That is a storage location for the received data. Okay, so that's all it is. And the way we receive the data is by defining a new array segment. Type byte. Pass in our buffer. It's going to be a bit annoying. Maybe don't tabulate it. And then we also pass in this cancellation token. And we just set it to none. Okay, and then finally, we call our handle message action delegate back with the result and the buffer. And this action delegate propagates back up to where the method is called, which we will do now. So let's use this method, and then we'll step through the code because it is a bit tricky. So back up here, we're going to go into this section here where we await the connection of our socket. We'll leave that here, and we're going to begin after here. So we're going to make use now of this await of this receive message method here. So we're going to await on it. So again, asynchronous programming, and we're going to pass in our WebSocket, and then we're going to use our action delegate here. So we call it asynchronously, and we're going to pass in result and a buffer. Don't know why I put that in like that. So again, this is really a lambda method, but we're using these two components here. So we call the receive message, we pass in our WebSocket, and then we call our action delegate, and we pass in, or we expect back actually, a result and the buffer that's received. So these are actually items that are going to be populated when this handle message eventually returns. So we call this method asynchronously, we wait while the socket is open, and then if we receive something on our socket, this method will trigger, and it will call our handle message action delegate with the result and the buffer, which will then in turn return back up here, and we're then going to process the result in here. So hopefully that made sense. It is quite difficult to follow, and I'm having a hard time trying to explain it. So we'll see it working. That might help. Read the blog article. That might help. But we'll step through it one more time once we've finished the coding, and it might start to settle into place. For me, actually, it took a while for it to kind of fit into place. So if you're watching this and going, what are you talking about? I don't get it. I don't blame you, okay, because it's tricky. So follow along with the code, get it working, and then it will eventually embed. I promise you it will. So effectively what we're doing now is we're going to have a callback from a receive message method, and we're going to check to see what kind of result we get. So we're going to interrogate the result, and we look at something called message type, and if it's equivalent to WebSocket message type text, which is basically a text message, then we're going to do something. Else if can also be a close message. So if result message type is equivalent to WebSocket message type close, then we're going to do something. We should do something else. So in here, if it's a closed message, we'll just simply, for the moment, we'll write out the console. Receive close message. And then we return. In here, if we get, it should be capitalized, that's why it's complaining, if we get, so actually just to show you the different message types we can get are text, close and binary. So you can receive a binary stream as well, but we're going to only deal with if we get a text type of message result back. Then for now, we're just going to write out, because there's a lot to take in here and I don't want to go too much further. Message received and return. And correct that. Okay. Now you can see that this is complaining as well now. If you just, let's just build it, let's save it, build it. Okay. And we get 2 errors. Let's have a look at what those errors are. Okay, I think we just got some syntax wrong somewhere. What did we do wrong? Oh, yes, up here. Okay. I think that should solve that. Yep. Okay, cool. Let's just save that again. Build it one more time. Cool, so we get a warning, right? And we'll clear this warning up later on, but basically we are calling our action delegate asynchronously, which is the right thing to do. But within the call to it, which is effectively in here, there's no await statements in here. So it's saying the same thing as we had before, that this async method lacks an await operator, so it will run synchronously. That's fine, it will run okay just now. So, just to try and step you through this again, if we have a WebSocket connection, then we attempt to connect to it and we await on this asynchronous accept WebSocket connection method here. We then have a connection. We then await on our socket to receive a message. So we jump down here into our receive message. We declare a buffer that we expect to be populated with any message that comes back, and we enter into this while loop that remains open while the socket is open. And again, we await on a method on our socket for any messaging that comes in on that socket. If we do get that, then we end up returning back our handle message action delegate, which then pops us back up here, and we then check on the result of that. Now this just keeps running in an asynchronous fashion so that we can do other things. That's the whole point of asynchronous programming. Again, over here in the blog, I do actually explain in much better, I can write explanations better than I can explain them verbally, as I'm sure you're starting to realize. I do actually take you through what's happening in the code. Okay, so let's try and run our server code and see if we can send a message from our client to it. So .NET run to run it up. Cool. And I think we've got an instance of our client here. Let's just reload it. So we'll connect in. Okay, so our connection's opened. We've got a message to our comms log. But one thing I'm just noticing, we can't send a message because our UI elements haven't updated on our client, so there's obviously something clearly wrong with our client. So let's go and have a look at that. What did we do wrong? What did I do wrong? So let's have a look at our update state function, and I think I see what the problem is. I think rather than this being disabled, I think this should be disabled with a D. I think that's the issue. So if we go into our switch statement on open, we should set our state label to open, and that happened. We call the enable function, which is this. So I won't update these. Let me just update these to see if that makes a difference. Let's reload. So if we connect, cool, that has actually worked. This hasn't worked though, so we're still okay. So we've got a wee bit of a problem there. Let's pop back over here then and have a look and make sure we've got everything. Yeah, so let's update all these disabled. And yeah, here. Okay, so again, this is a reason, and it's because I'm a bad JavaScript programmer, I'll put my hands up to that, but it's also a reason why I hate it, because it wasn't erroring out, it wasn't giving us any issue. For me, JavaScript is just, I don't know, it's just stuff like this kind of winds me up. Anyway, hopefully we've caught everything there, and okay, I don't know why, but I think, yes, we've not put in everything we need in our default statement, so that should disable everything really. And yeah, we need to break that as well. Okay, so I think that should be us fixed. Let's refresh. So yes, we're testing our send message functionality, so let's connect in. Cool, so that's disabled now. Okay, let's just put a message in, any old rubbish. Click send. Excellent. So we've now received our message. Now the other thing that you would have noticed, when we connected, we didn't immediately get a disconnection, and that's because we've entered into this while loop while the connection is open, but it's also open in an asynchronous way. So what that means is we can also put a localhost request in on a HTTP connection, if I can get my act together and hit the right key on my keyboard. So again, it's running asynchronously. We can still put HTTP requests through the request pipeline, and our WebSocket connection stuff is still running. So yeah, it's all good. And then we got our output from the console from our request we just made here. And theoretically, we could fire up another client. In fact, let's do that. Open the Firefox, and we can connect in on that. We get a WebSocket connection, and we can send messages on that. Cool. So that looks like everything is working. We are sending messages. We're not yet displaying what that message is, but we are receiving messages on our client, and we are receiving messages on our server from our client, and the connection is staying open in an asynchronous way. All right, so we move on to phase 3 of our build, and in this section we're staying completely within our server application, and we're really going to just upgrade. When I say just, we're going to upgrade the middleware that we've already written and spin it out into a separate class. So it's not really going to impact the functionality that we're developing, but it's just going to make our code a lot cleaner and adhere to kind of some fundamental principles. So it's definitely worth keeping in. So let's move back over to our server application. And the first thing we want to do is add a folder at the root, and we'll call it middleware, assuming we can spell it correctly. And I always seem to capitalize the I, so there we go, middleware folder. And in here we're going to create a new class, and we will call our class WebSocket Server middleware.cs. And I'm surprised it didn't actually put in a namespace for us. Anyway, WebSocket Server middleware. Save that. Okay. And we'll add a few using directives at the top that we will require to get this up and running. So system.net WebSockets system text system threading system threading risks. And then finally, not system, Microsoft ASP.NET Core HTTP. So our class is public, that's fine. First thing we want to do is create a private member variable, read-only, and this is actually our request delegate that we need to define in order for this to work. So basically what we're going to do is we're going to replace this with something like this. And by spinning it out into a separate class, that's enabling us to do that. But in order to do that, we need to set up some scaffold type code, if you want to call it that, in order to get this working. Now again, on the blog article, there is links to some Microsoft documentation on how you should structure your middleware classes. And it follows a specific standard pattern, and this is basically the pattern that I'm just following here. So then next we want to create our class constructor, WebSocket server middleware, and we pass in via dependency injection our request delegate. And we assign it to our private instance. Now again, dependency injections are a huge area on its own. I may do a video on that at some point, but basically via our configure services method, although it's not specifically defined here, it is available to us through dependency injection. We will get an instance of request delegate passed in, and we'll assign it for use here. Okay. And we'll come on to a bit more about dependency injection a bit later on when we actually utilize it in a bit more detail. And then the sort of final thing we need to wire up is really a public invoke async method, which is asynchronous, returns a task, and we'll call it invoke async, and that accepts a HTTP context. Now that is basically our standard pattern setup, and all we're going to do in this method here, we're just really going to cut and paste the code that we already have from our startup method here. So basically just copy all of this here and paste it into here. And we're getting an error because we don't have a receive message method, so we will need to copy that over as well. So we come here, I'm going to cut that out and paste it over here. Now instead of awaiting next, we will await on our private instance and pass over our context, so that we will call the next request delegate in our pipeline if that's required. So let's save that and save our startup class. And in fact, we'll take this out as we don't need this save. And then the only other thing we're going to do in here was, if you recall, when we received a message, we didn't actually display the message on screen. So that's, well, we didn't display it within our console log. So we're going to change that now and just write that out to the screen, so it makes it slightly more useful. So we'll just write out our message to the console using a write line method. Print our message, and we're using this $sign, which will allow us to interpolate our variables within our string, and it will print it out or display it as a string. So unfortunately, we've got to use this we've got our buffer and we need to basically decode it using UTF-8. So we take our buffer, start at 0, and then go to the end by using the count length. Okay. And it should display it, hopefully. So the way that we can reintroduce our middleware into our pipeline is to expose it through an application builder instance, and the way we do that is by creating another class in our middleware folder. So let's do that now, and we'll call this one WebSocket. This is either getting quite long, these names. Server, middleware, extensions, .cs. Okay, so I created a file that time rather than creating a class, which is not kind of given as the basic stuff that we require, but that doesn't matter. So the only using statement we need is Microsoft ASP.NET Core Builder, and our namespace is WebSocket Server Middleware. And our class this time is actually going to be a public static class. So we don't have an instance of it, it's just a static class that we can use off the bat. And we'll call it WebSocket Server Middleware Extensions. And then basically what we do is we expose our middleware class through an iApplication Builder instance. So we, again, public method, static. And again, if this is a bit confusing for you, I'm not going to go into too much more detail about it. There's a link to a good article from Microsoft in the blog about how this all works. But basically we're creating a method, a static method that we can use in here. So you can see this one's called use WebSockets. If we go back over here to our middleware, we're going to create something very similar. We're going to call it what we like, use WebSocket Server. And that method we can use via this static instance, this static method call. We merely pass in iApplication Builder. And then all we do is return builder, use middleware. What are we going to return back? We're going to return back one of these here. So let's just copy this in to make sure there's no mistakes. Cool, so we save that. And hopefully, if we've done everything correctly, let's clear that, and we do a .NET build. I do need to be able to spell it right. It should be okay. We'll get that warning, same warning, it was just moved into a different class about our asynchronous method running synchronously, but that's fine, we can ignore that for just now. Let's run it. And so we should see absolutely no difference in how our client behaves against it. It should just be exactly the same. We've not changed our client, but if everything's running as it should, actually this won't work for a very obvious reason. If you go back here, we haven't added it into our request pipeline, so let's do that. So let's just stop that and come back over to our startup class. The first thing we actually need to do is add a using directive to our middleware folder. So it's just an internal reference kind of, but we're referencing the WebSocket server middleware namespace. And then within here, we want to find this method. This method should be available to us now. So app use WebSocket server, there it is, it's there. Now, if all is working correctly, then we should be able to run this now, and as we were trying to before I forgot to put this in. So let's save that. Let's just do a build. Okay, and then .NET run. Okay, let's just restart our WebSocket and bring up our server actually so we can see what's going on. And there should be no difference. Connection opened. Actually, there will be a difference. We can should be able to see our message now. Should be displayed if we did that correctly. There we go. Cool. So message being received as before, but this time we're displaying it onto our console. So that's the end of this build section. It was quite brief, but it was worthwhile taking our our request delegate and moving it into a separate class, because I'm sure you'll agree this looks much nicer and much more professional now. So section done, let's move on. Okay, so we're moving on to phase 4 of our build, which is adding a management layer to our application. Now, what do we mean by that? Well, let's demonstrate what we mean by that. So we've got, well, I've got 2 instances of our client up and running. We've not connected yet to our server, so let's do that now. So we've got 2 connected instances of our client, which is fine, and we can even send messages. So from 1, hello from 1, send, hello from 2. Great, so that's all working, and in fact we've actually used everything that there is to use on the WebSocket API. It's a relatively simple API. So the state we're in, we've got this kind of central server as a hub, and then we've got multiple client endpoints all connected in, but they're unaware of each other. So what we need to do is add a manager, or a manager class, to basically allow us to perform some routing, and more especially identify the client endpoints to allow for that routing. So we're going to introduce a manager, and as part of that manager we're going to track our connections and give them a unique ID that we can then use to perform some kind of routing functionality. So that's what we're going to do now. Alright, so let's move over to our server application. We're going to add our management class, which will do 2 things. It will generate a unique ID for us for each connection, and it will store that connection against all our WebSocket connections. So we can put this class anywhere we like. I'm going to put it in our middleware folder. It just probably is a bit neater and tidier in there. So a new class, and we'll call it something like WebSocket Server Connection Manager. Not something exactly like that. So that's added in. Let's add our namespace, WebSocket Server, middleware, and we need a few using directives in order to get this all up and running. So first one is using system, second one is system collections concurrent. And the reason we need that is in order to store our WebSocket connections, we're going to use something called a concurrent dictionary object, which is why we require that using statement. And then finally, system.net WebSockets. So let's create our concurrent dictionary as a private instance. There we go. And it just stores key value pairs. So we're going to store a string, which will be our unique ID, and then our WebSocket. I'll call this sockets. So we'll create a new. Cool. All right. Okay, so we've created a private instance of our concurrent dictionary. We want to expose that as a method, a public method. So we'll call it something like get all sockets. So what we want to return is a concurrent dictionary of string WebSocket, and we'll call it get all sockets. So this is just as us exposing this private instance to the rest of the world, and we're simply just going to return sockets. Cool. And then the last thing we actually want to do is add a method called addSocket that will allow us to use this manager to add sockets to it. And as part of that method, we'll generate a unique ID for that socket. It's pretty simple, but necessary. Okay. So we'll make it public. We'll make it return a string, which will be our unique ID that we generate. We'll call it addSocket. And we'll expect a WebSocket. So let's create a string called conID and we'll generate a GUID. A GUID is just a unique identifier. You'll have seen them around, I'm sure. In fact, well, you'll have seen it at the demo at the start of the video. And we'll just convert it to a string. So we create ourselves a new GUID and we'll store it in here and we will return that back. And in between returning it back and generating it, we will add it to our concurrent dictionary using the try-add method. So we'll try adding conID and the WebSocket that we passed in. And just to make sure, for our own sakes, that we believe it's working, we will write it out to the console log. Something like connection added. I'll pass over the conID. Save that, and then we'll build it. Okay, so we actually want to use our connection manager in our code, so we will pop back over to our WebSocket server middleware class, as that's where we're going to make use of it. And the first thing that we want to do is create a private instance of it that we can use. So private read-only. WebSocket server connection manager, and we'll call it manager equals a new. So just before we move on, you know, we've got this, we're instantiating a request delegate like this, and because it's available through dependency injection, we can set it up through our constructor in this way. We're kind of using a different method now by using a new statement to create a new instance of our WebSocket server connection manager, which I don't really like, but we'll circle back to that in a bit. Anyway, we've got our manager up and running, and so what we want to do is, after we have connected, we can just call the add socket method on our manager. But what I also want to do, because I may want to use it later, is I'm going to create a string, call it conID, and we'll pass in the return value from addSocket, should I say, and we'll pass in the WebSocket. So just to go over that again, if we pop back to our connection manager class, we actually pass back the conID that we generated. I'm just putting it in here because we may want to use it later, and we're adding the WebSocket that we got a connection on. So let's save that, let's build it, and let's run it. And what we should see every time we connect in, our WebSocket should get added to our manager and we'll get a unique ID. So let's just bring our clients back up, and we don't really need to refresh because they've not changed, but if we connect now, we have a connection added for this connection, and we connect on this one, we'll get a separate connection ID on this one. So we're still not there yet, but we're moving towards tracking our client endpoints via unique GUIDs. So we're stepping towards being able to route between clients. But before we do that, I just want to tidy up our connection manager code. So going back to our code over here, what I wasn't too happy about was how we've created our private instance here by using this new keyword. I would like it to look something a bit more like this, but in order to have it look like this, we need to use something called dependency injection. And what that means is that we basically tell our application where it can get an instance of this class without having to explicitly create it like this. And we can even take it further by using things like interfaces that I'm not going to cover. So in order to do that, what we have to do is, if we go back over to our middleware extensions class, where we have our iApplication built, where we have our use WebSocket server, didn't want to do that method, returning an iApplication builder, we're going to add another method in here that we will basically put into our configure services method. Now, just refreshing your memory, our configure services method is where we set up services or dependencies that we want to use throughout our app. Now, some of those dependencies are created out the box, we don't need to do anything, but some of them, like the dependency we're going to create now for our connection manager, we will have to add it in here explicitly. So in order to do that, if we go back over to our extensions method class, we're going to create a method that will allow us to do that. So again, public static, and this time, actually before we do that, we need to add another using directive. Dependency injection, and we want to create an iService collection. And like how we created this method name here that we can use elsewhere in an application, the method name we use here, we can refer to it in our startup class. So let's call it something like add WebSocket manager. Keep it a bit more brief than we have some of our other names. And we'll pass in this. We're basically adding it to the existing iService collection called services. And we're going to say services. Now you get a number of options here that allow you to register your dependency in various different ways. I have put links again to it in the blog. We're going to use add singleton to add our manager class to our services collection. Make sure we add the right class, Web Service Connection Manager. And we'll just return our services collection that we've added this to. So we'll save that. And then back over in our startup method, we can actually use it. And if you just tabulate that, we should have it. Here we are. Add WebSocket Connection Manager. And so basically what that's doing is it's calling this method here, and we're adding an instance of our WebSocket Server Connection Manager as a service that is available for use throughout the rest of the application. So what this means then is back over in our middleware, we don't need to use this. We can get rid of that because our application already knows what it is, and it doesn't need to actually explicitly create it using the new keyword. But what we do need to do is we need to add it into our constructor here, because that's where it's going to get pushed in. So we're going to push in a WebSocket Server Connection Manager, and we'll call it Manager. And then in the same way that we've defined our private instance next, we will define our private instance manager with whatever is being pushed in via our constructor to manager. So again, dependency injection, I found it quite difficult. I found it actually very difficult when I was learning about it. It was quite confusing, and it went against everything that I kind of knew. But once you get it, it is actually very powerful. So just to reiterate, we have set up this static method called add WebSocket manager. It adds it to our services collection, and then we can reference that in this way here by using dependency injection and using a private member that we assign via constructor dependency injection. And also over our startup class we have to add it to be available. Now if this was not here, then we would have some problems. So again, you can save that and we can hopefully run that and it should work. So again, it's not changing the functionality of our code, but it's changing the maintainability and the readability of our code. So let's just refresh this. We'll connect. Yep, and we're getting exactly the same result. Okay, so before we move on to the next section, which is adding a router, one thing that we still have to do in this section before we finish it off is pass back the connection ID to the client. So at the moment, the client connects in, the server generates an ID and adds it to a collection of connections. That's all great, but the client is still totally unaware of this connection ID, which it will require in order to basically, what we will require in order to perform routing. So back over on our code, let's shut down our server if it's not already shut down. And we want to add a new method into our WebSocket server middleware class, which is basically where all our functionality is, or the majority of our functionality is now sitting. So we're going to create another asynchronous method. You won't be surprised to hear. We'll make it private this time because it's just for use with our server. And this should be very familiar for you now. This should be very familiar for you now. Using the async keyword and also returning a task. We'll call this send con ID, and then we'll put async at the end of the name to kind of maintain the naming convention. We'll pass in a WebSocket, call it socket, and we'll also pass in the con ID that we want to send back. And this is going to be relatively simple. You can see here it's complaining again, it's giving us the same complaint. We've defined an asynchronous method, but we're not using any await statements in it. But the first thing we want to do before we do that is create another buffer, and we're just going to encode our string so that we can pass that buffer in the next following method. So we'll use encoding. Not encoder, encoding, UTF-8, get bytes. And then we're going to encode the following string, con ID, just as a kind of static, not really a header, but just a kind of prefix to what we're going to send over, because we will be using this on the client side. And then we'll pass over our con ID. And then we want to basically take that buffer and pass it over to our, send it to our client via the send async method. So we've already used receive async. This time we're going to use send async. And what do we send? We send over the buffer that we've just created. WebSocket message type text, indicates whether the data in the buffer is the last part of the message, true, and then finally the cancellation token, none. And that should be enough. So that's our send con ID async method, which we will call to send our connection ID back to a client. So to make use of that, we will go back up to our main invoke async method, and after we have added our socket to our manager, we will call this method and send it back. So we want to await on it because it's an asynchronous method. And we'll do send con ID async. And we will pass in our current WebSocket that we are receiving messages on, or receiving a connection on, should I say, sorry. And we'll pass over the con ID that we have stored from our previous operation here. Fantastic, so let's save that off. And what we should be able to do, if we do a Control-C on this, do a .NET build, okay, and then .NET run. What we should get now on our client, we don't really need to refresh it, but I'll refresh it anyway, is when we connect, we should get a message back from our server with the con ID. And indeed we do. So we have now received a message back from our server telling our client what connection ID it's been granted, and as you can see here, they match. No surprises there. So we could leave it at that. And in fact, yes, we could leave it at that, but we won't. One of the things I wanted to do was actually pass the con ID and display it on the screen in a slightly nicer way. So let's do that now. So let's move back over to our client code, and we'll just update that so that whenever we get a string of this format, we will populate the value of our con ID. So let's move back over to our client application. Here we are. And we want to add in, first of all, we want to add in a new support function. So here are all our support functions. We're going to add another one in. And all this is going to do is it's going to look at a string and try and determine whether the message is a connection ID message. It's quite crude, and we're actually going to change our messaging in the final build section, build 5, but for now we're just going to do it this way, which is fairly basic, but it works. So we'll create a function, we'll call it isConID, it will accept a string, and then all we do is we determine if the string, if the substring of our string, and we provide a start and an end. So we're going to say between 0 and 7 is equivalent to con ID colon. So basically, popping back over to our server app here, yep. When we create, if we get the right place, yep. When we create our string, we're going to basically look and see whether the first 7 characters are this. So it's subject to a bit of abuse, but for all intents and purposes, it's make sure we put the space in. It's fine for us. So we won't put a space in. We'll just do that. And if so, then we will reference our con ID variable and update its HTML. And in the same way that we pulled apart the string with substring, we also use it to display the GUID. And because we know we're getting a GUID back, we know it's of a particular length, fairly comfortable that this is going to work. It is it's a very crude method, but we're going to upgrade to JSON messaging later. I didn't want to introduce that just yet though, so this should be okay for now. So the only other thing we then want to do is every time we get a connection, or every time we get a message sent back, then we want to just check to see whether if it's a connection message. So up here on our onMessage event, we will just call that function as conID, and what we want to pass in is the event data. And we'll save that. So this is still running, so if we refresh our client, what we should see is when we connect, yep, we get our message ID, we've run our new method, and it has in fact determined that yes, it did start with con ID, so we've updated our messaging up here. Not strictly necessary, but just a nice simple function to round off this build section before we move on to the final, you'll be pleased to hear, 5th build section. So we come on to the last part of the WebSocket build, and I'm sure you'll be pleased to hear. I'm pleased to hear it as well. It's been quite long, hopefully enlightening though. And so in this last build phase, we're going to be building the routing functionality of our application. At the moment, we just have clients. Yes, they're now uniquely identified, but they still can't send messages to each other. So we're going to remedy that in this section. And the other thing we're going to do is we're going to gracefully close out the WebSocket connection if we get that request from our client, which we've not done yet in our server. So that's all to come in this build section. So first we'll move over to our WebSocket client, and in here we're going to create a new support method that's going to basically construct our JSON payload message. I'll quickly show you the article online so you can see what that will look like. This is some very simple JSON. It's key value pair object. So we're going to have a from component, a to component, and a message. Should be fairly self-explanatory. In terms of our routing rules, they're very basic. If we have a to component present, then we're effectively going to send a message directly to that client. We will check to see if we're still managing that connection on our server. If not, then we'll error out here. If there is no valid to component present, then we're just going to broadcast message send to every connected client, and that's basically about it. So we're going to construct a function in our function. A function in our client, we'll call it something like construct JSON. And you kind of get JSON functionality out of the box with JavaScript for very obvious reasons. So we're going to just return a string, and we're going to use the JSON object to stringify a number of components that are available to us on our client application. So we're just going to take elements from our UI and build it into a string that is adherent to JSON, the JSON standard. So the first component is going to be a from component, and the value of that is going to be our con ID in our HTML. But if you remember, the con ID is comprised of the word con ID plus the GUID, so we want to strip that out using the substring method again. So we're going to start at position 8, and we're going to go all the way to the end of that particular string. So con ID in our HTML length will get us to the end of the string. So that's our to component. That's our from component. We're now doing our to component. That's simply going to be the value of recipients. And then finally our message component is going to be the value of send message. Very good. Okay. And then all we want to do is in here, in our send button message, here we constructed, but here we just passed in the value of send message. Instead of doing that, we want to construct our JSON payload instead. Simple as that. That's all we need to do. We just need to change that. And so the data that's now being passed over is our JSON string. So we can see that at work if we go back to one of our clients and refresh it now. So yeah, let's just test that. Let's connect in. Cool. And we'll type a message, and we'll just put anything in recipient ID. If you click send, yep, there we go. There's our JSON message there. Our from should be equal to our con ID. Looks like it is. Our to is just this garbled nonsense, and the message is hello. So that all looks like it's working correctly. If you go over to our server, received. It's just a string as far as it's concerned at this point in time. So what we now got to do is pop over to our server and deal with that message. Right, so back over in our server class, let's just make sure that's stopped. Okay, we are going to add our routing functionality to our server. So in order to do that, we need to add a couple of new using directives. The first one is adding JSON capability, and you get that through the Newtonsoft JSON namespace. And then the other one is using system link. I can't remember what link stands for. Language, I can't remember. It's like a query language where you can use to do queries on objects and stuff, so it's very powerful, and we will be making use of that in a bit. So yes, we're in our WebSocket server middleware class, if I hadn't already mentioned that, and having added those two using directives, we want to add a new support method, I guess you'd call it. We're going to call it public async task route JSON message async. And all we're going to pass in is our JSON string called message. So remembering back to the flow diagram we had on our routing rules, the first thing we want to check to see is if the to component of our message string is a valid GUID, and if it isn't, then we're just going to broadcast. So let's start to code that up. Before we can do that though, what we need to do is take our message string and deserialize it and turn it into an object. So that's all deserialization means. We're going to get a serialized or a string, a JSON string over the network from our WebSocket, via our WebSocket, and we're going to take that and turn it back into an object. So Newtonsoft JSON allows us to do that. So first things first, we'll create an object to hold our JSON. Call it anything you like, we'll call it route OB, and then we use the JSON convert deserialize object method to deserialize our string. It's going to ask us what do we want, what object do we want to deserialize it to, so we can provide a concrete object specification to it if we want, or we can just say you decide, and in order, that's what we're going to do. So if we want that approach, then we just say dynamic, and the deserializer decides what the object is at runtime. And what do we want to deserialize? Our message string. Cool. What this does mean though is the route OB object is kind of loosely coupled, so we don't really know what the attributes on it are until runtime, which can cause some problems, but it should be, in terms of proving a concept, it's fine for our purposes. So the first thing we want to then do is see if the to component is a valid GUID. And you can do that a number of ways. You could look at, you could use regular expressions and that kind of thing, or you could do it more basically than that. I just decided to use the GUID try parse method, which basically takes a GUID, it tries to parse it, and if it's successful, it passes out that GUID. So I'll pass in route OB. Now, this is where we're not getting any IntelliSense drop down to tell us the attributes available, because we simply don't know. So we're just going to put it in. We can use it as if it was there, but it may throw us an error at runtime. ToString, and then we pass out another GUID. That's just the, we're not going to do anything with that. It's just a requirement of the method signature. So if that does pass, then we've got a valid GUID in our to component, and we'll do a targeted message. Otherwise, we'll do a broadcast. So let's deal with that first. So we'll do a quick console write line. Somebody in a motorbike going past the window there. Whoop. Write line, and we'll just say broadcast. And then if it is a broadcast message, what we want to do is we want to cycle around all our open connections in our manager and just send a message to every one of them. So We'll do a for each loop and declare a temporary variable, call it anything sock in our manager, and we'll have to call the getAllSockets method to return our dictionary list, and then for each one we're going to check to see if the socket is open. So if sock value state is the equivalent to WebSocket state open. Basically we don't want to send something to it if it's not open, then we're going to use the sendAsync method again. So it's an asynchronous method, so we use await. We'll reference it by going through the current sock object. We have to use this value object to get to it, and then we call the sendAsync method. So you should be familiar with this now, so I'll just type it in as you've seen this before. So it should be relatively familiar to you now. If you want more information on the sendAsync method, probably best just to look at the documentation. In short though, we're just sending over our message string, or the message component of our string. And we will .NET build. .NET run. Client hasn't changed, but I'll just refresh it anyway, and let's bring up our other client as well, and we'll refresh it. So let's connect in, we get a good, connect in, we get a good. Let's just go hey. Now we've not called our routing method from within our function, so before we do that, before we can test it, we actually need to call this. And so where we want to call it from is back up here if we receive a message. So if you remember, we when we receive a valid message, we come into this, we call it, well, we've received it from our receive message method, and then maybe enter into this action delegate stuff. So we want to just add it in after we've accepted, or after we've received a type of message text. And we should be able just to pass through this here. That should work. Okay, so let's try that again now. Let's save that. .NET run. And then if we go back to our client, we shouldn't, well actually let's just reload them. Connecting again, connecting again. And we'll put a message in, but no recipient ID, so it should trigger the broadcast. There we go. So you can see here that it has decided that it was a broadcast, and it has sent it to all clients, including the sending client. So that's all working, which is good. So let's just cancel that for just now. So we now have to go back to the targeted part of our router. So we'll just write out to our console that it's targeted. We'll then declare a WebSocket, an individual WebSocket object, and we want to retrieve back the WebSocket that we're getting the message on. So we go to our manager, get all sockets, and this is where we use link to select a specific WebSocket. I'm assuming the socket isn't null. We'll check to see whether it's open or not. If it's not open, we'll just deal with that case first. We'll just say valid recipient, so we're not managing that connection, but assuming that it is okay, actually this should be here. Save it, kill the server, and we'll run it again. Just refresh these, connect in again, and what we'll do is we will copy the connection ID from this client here, put it in our recipient ID, and type a message. Doesn't matter, I've spelt it incorrectly, and you can see here we have a targeted message and we only receive the inbound targeted message from this client. We get the outbound message on our sending client, but we don't get the broadcast message. So that's our routing functionality completed. Okay, the last thing we need to do in this section before we move on to SignalR is make sure that we close our WebSocket connection gracefully upon receiving that from our client. So if we move over to our code, we aren't really doing anything in this clause here. So we called a receive message method, and then if we received a text message back on it, we perform our routing functionality, but we can also receive a close message, and at the moment we're not really doing anything with that. And again, if you've noticed, when we've stopped the server from running, you'll often see a lot of complaining and error messages being thrown around because we've not really closed down our WebSockets cleanly prior to the application closing. And this adding some code in here to close those sockets gracefully will go some way to remedying that, but that relies on us actually closing the socket from the client. If we choose just to kill the server application, then I'm not dealing with closing off the sockets gracefully when that happens, and it's probably something you would want to consider doing. Well, not something you probably would want to consider doing, it's something you absolutely would have to do if you were building this in a production type environment. But for now, we're going to add in some code that will close off our sockets gracefully if we request it from the client, and then we're going to draw a line under our WebSocket app. I think it's in a sufficiently decent state that you understand what WebSockets are and just the amount of work that you need to do to get them up and running. So back over in our code, we're going to add some amendments. I will just kill this first, and again you may see that complaining messaging popping up at some point. Yeah, here we go. It's complaining, which is what you would expect. So the first thing we want to do if we receive a close message is just to get the ID of the WebSocket that sent us that close message. So we do it in the following way. Create a string called ID, and then using our manager object, our manager class should I say, well it is an object really, we'll get all sockets, and then using link, it's not seeming to, here we go, first to default. Sometimes I find IntelliSense in code, VS Code doesn't work quite as I would expect it to, but nonetheless it's usually pretty good. So S goes to S value, and if that equals the WebSocket that we've received our message on, then we want to bring back the key, which is our con ID in this instance, and so we're popping that into our string ID. That's quite annoying. Okay. Am I going to get rid of it? No. Okay. What we're then going to do is we're then going to try and remove that WebSocket connection from our manager so it's no longer being managed before we close it off. So we'll call the try remove method, and into it we will provide our ID, which is effectively our key, and out of that we are going to be supplying a WebSocket, and we'll call it something like sock. So that's what the try remove method on our dictionary does. It will take an ID, if it finds it, then it will pass out the WebSocket in this instance that we can then work with and close. So we'll then, I just want to get rid of this message, it's really annoying. Okay, so we'll then await on our passed out socket object, and we will close the connection. And that should be the method completed. Okay, so we'll save that, and what we should now see, well, let's build it first. And then we'll run it. Our clients again haven't changed, but if we refresh, we'll reload it and we'll connect in again. If we click close socket, we get a different reason code, the clean reason code of 1000, and we should see something, I'm assuming, on the server as well. Yes, we received, well, we're just printing out we received the close message. And we only had one socket connection there, I believe, so if we kill the application, it shouldn't complain from this point forward. So that brings us to the end of our WebSocket build. You can see that on the JavaScript side of things it's relatively straightforward, although I don't like JavaScript. It's not that complicated. On the .NET side of things though, you can see that it's a lot more complex. Now we did some additional steps just to tidy the code up that we didn't really need to do, but I think it was still worthwhile doing. And the other thing to point out, by no means what we have written here is it suitable for any kind of productionized application usage. There's still a lot that we would need to do there to tidy it up and make it robust enough that it would be something you would actually want to use, but hopefully it gave you enough insight into how you can start to think about using WebSockets in .NET. We now move on to the SignalR discussion, and we build an app. Don't worry, it's a lot quicker, much quicker than the WebSocket build. Alright, so we're going to start with our SignalR build. And before we do start with the coding, I'm just going to pop back over to the blog article and show you the architecture of our application. Now it looks very similar to the WebSocket application. On the left we have the HTML and JavaScript client. The only difference is that we now need to include a external SignalR JS or JavaScript library. And then over on our server application, our .NET Core application, we only have one class that we need to create, and that's a chat hub class based on or inheriting from the hub class from SignalR, and I'll talk a bit about that in a minute. Other than that, it's basically doing the same kind of thing. It's requesting an upgrade and to a WebSocket connection and then establishing a WebSocket connection. So that's our very simple architecture. Looks very familiar. Let's now move on to the coding. So let's just move that off to the side for the moment. I'll refer to it again, and let's open VS Code once again. And I'll change into my F drive to start from a nice clean slate. Okay, so as usual, we want to do a .NET new. We want to build a web template application. We'll give it a name, SignalR, capitalize the R, server. We're ready to go. So yeah, we're starting with the server application first, and then we'll do the client application. Okay, so let's open that folder now. Go into an F drive, SignalR server, that up. Cool. Okay, so we got the usual standard web template project with a program and startup classes. Let's just say yes to that. Now the first thing we want to do, referencing back to the architecture diagram, is to create this hub class. Now hubs are a central concept in SignalR, and they're really essentially responsible for handling the connections and also managing the messaging. So they basically replace the custom classes that we wrote in our previous WebSocket application. So we're going to create a hub class now. That's the only thing we need to really create to stand up our SignalR application. So as per sort of Microsoft guidelines, you want to create a folder called hubs. I guess it's just keeps it nicely organized, and then we're going to create a file within that, and we're going to call it chat hub. If I can spell it correctly, chathub.cs, make sure it's a JavaScript, a C# file. See, I knew that would happen. I knew I would get confused if I was doing two programming languages in the one video. I'm not that intelligent. Okay, so we've got our empty class, so let's get coding on that. So first our includes, so we're going to do a few using statements. System shouldn't come as any surprise. Using Microsoft ASP.core SignalR, and SignalR is included in the main ASP.NET Core package. We're going to use system threading tasks, and then finally we're going to use Newtonsoft JSON, as we did before, to deserialize our JSON messaging. And again, Newtonsoft JSON at the moment, as of .NET Core 2.2, is included with that. I have read somewhere, I think with .NET Core 3, they might be swapping that out as the default JSON package, but I'm not sure about that. So our namespace, and that should be the same basically as our project, SignalR server, and then our class, chat hub, make sure you spell that correctly, and that inherits from hub. Okay, so it basically inherits from hub, and we're going to actually override a couple of hub events, connection, and I think we're just doing the connection, unconnected. Yeah, we're not doing the disconnected, unconnect. So we can send back the connection ID when we connect. Okay, cool. We don't need a constructor or anything like that. So let's do that first. Let's override the onConnect unconnected event. And it's an asynchronous method effectively. So we pass back a task, as you're now familiar with. And yeah, let's do a console write line just so we can see it's connected. So we can write that out to and actually, so one of the great things with SignalR is that previously we had to create our own management class that would generate unique GUIDs, connection IDs. With SignalR, that kind of comes out of the box, and the way we reference the connection ID for any connection is to reference this context object here, the hub caller context, and then simply within that there's something called connection ID. That's the connection ID of our connection. How simple is that? Okay, so when we connect, it will write out that connection ID to the console. And then all we need to do on the connected event is send that connection ID back to our client. And all we do to do that is we reference this client's object as a collection of clients, I guess. The client that we want to send to, and we want to send to the client with the given connection ID. So client, what client do we want? We want the client with this connection ID, so it's kind of almost self-referential, and then the method we want to use is send async. And then the method name that's going to receive this event on the client side. We can call this anything we want, but I'm going to call it receive con ID. So what this means is this is actually going to be a method or a function over in our SignalR JavaScript client that we'll have to write, and it will receive this event invocation and do something with it. So you'll see that when we come on to doing our client application. And then the next thing we want to send over is our context connection ID. There we go. So just to reiterate, when we connect, we'll write this out to our console so we can see it's writing, and then we're going to reference any connected clients with this connection ID. There should only be one, of course, and then we're calling the send async method to call this function over in our SignalR client. And then just so we're adhering to the overridden event or method, we are just going to return, if I can spell it correctly, a base on connected async. And that should get rid of all our errors. So we will just get a console up and we'll do a build. And that should all build okay. Right, so let's move on to our send message method. And this is the method that's going to get called by our SignalR client to send messages to other clients. So it's kind of like our routing. Method in our WebSocket application. So public async passes back a task, send message async, and we'll pass in a JSON string called message, exactly the same JSON string that we passed in with our other application, so that's not going to change. Cool. Now the first thing we want to do is deserialize our JSON string and make it objectify it, deserialize it. And we'll put it in an object called routeOb, JSON convert, deserialize object. What type of object? Again, we'll use dynamic. Again, you could place in there a concrete class that mirrors your expected JSON payload, but we'll just use dynamic for now. And what are we deserializing? Well, we're deserializing our message. Cool. Now, what we'll do just to keep the verbose console output going. We'll do a console write line. And we'll just write out that we've got a message received. Message received on. And we will use the context con ID one more time, connection ID. Shortened to con ID. And of course we'll put a plus in there. Okay, so that's just going to give us some output on our console, server console. Now, the other thing I'm going to do, maybe I'll put it up here actually, is I'm going to create a concrete string called to. Is that a good name for it? Maybe to client. Yeah, that's better. And what I'm going to do is I'm actually going to use the route OB to component and actually place it into that concrete variable. Now the reason I'm doing that is because I've discovered when we come later on to call this method and place in the connection ID of the recipient, using this construct, I believe because it's dynamically typed, it actually errors out for some reason. I guess because it's dynamically typed. So what I've found is if I actually parse this object and parse this attribute of that object and put it into a concrete variable and then use that concrete variable in here, it all works fine. So that's why I'm doing that. I didn't investigate it much more than that, but that's why I'm doing that. So we're then just going to determine whether we want to send to one client or whether we want to set or whether we want to broadcast. Now, just for quickness and simplicity, because this is becoming quite a long video, I'm just going to check to see whether this to client string is empty or not. So that equals string empty. So if that's empty, I'm not parsing to see if it's a correct GUID or anything. If it's just empty, then we're just going to do a broadcast. And the way we do that is await, and we call clients. Again, very similar to what we did up here. Have to spell it correctly first, clients. And instead of targeting a specific client, we target all clients. And therefore we don't need to pass in a connection ID. We simply call send async. And then again, we specify the method on our client that we want to call, receive message. And we'll create this method or this function over in the JavaScript client in the next section. And what do we want to pass over? We're just going to pass over the whole payload to all clients. So that's our broadcast message. So that is if this to string is empty. Otherwise, we're going to basically copy this. We're going to copy it, we'll type it out, but basically replicate that method call. So again, we'll await clients, client. Now, this is where I'm saying I had an issue. If I was using this and it was not liking it, saying it was a null object, I believe. So if we use this, it should work fine. And then we just do send async. What method are we sending it on? We're sending it to the same method as this one here. And what we're sending message. It's as simple as that. Now we could put in some console write statements, which I actually did when I was developing this. You can as well, just to see what's happening, but I think it's fairly straightforward. So our hub class, we have two methods. We've got this override method, which is basically our connected event, where we send back the con ID to the client, and this other method, which is our send message method, where clients call that method to send messages to other clients. That's our hub done. Okay, and so we've only got a couple of little bits of code to put in our startup class, and we're done with the server build. So let's move over to our startup class. And again, well, actually, before we do that, let's just do a build, just to make sure the stuff we just did is okay. It looked okay. Now, just out of interest, my F drive's actually on an external hard disk, so I think that's why it's taking a bit longer to compile, I'm going to guess. So yes, we're back over, and well, actually, we didn't save it. So let's save it, I always do that. Let's build it again. And yeah, it's fine. Cool. So back over in our startup class again, this is our new project. So I'm just going to delete this just to keep the code clean. Get rid of all this. And also get rid of this. I'm not saying this stuff isn't important, but just to keep it nice and simple and you can see exactly what's going on, then I like to just clear it out as so. So you're quite familiar with both of these methods now. Configure services is where we set up any services that we want to use through dependency injection, and our configure method is basically where we set up the request delegates that make up our request pipeline. Now, the beauty of SignalR is we don't have to write any of this extra stuff ourselves. It just comes out the box with SignalR. So the first service we want to add is add CORS. Now CORS is cross-origin resource sharing. What is that? We'll come on to that in a bit. So we're going to add CORS services to be available for use throughout the application. And then the other service, can anybody guess what we're going to add? We're going to add SignalR, okay? So again, that adds our SignalR services available within our application. And that's it. That's our configure services method done and dusted. So we move on to our request pipeline now. Now, the first thing we're going to add to our pipeline is this cross-origin resource sharing. So app, use CORS, and then we're going to use a builder to build up some attributes that we want to use as part of CORS. Now, it's probably a good point to actually go over what is CORS, cross-origin resource sharing. Quite a simple concept, really. It's basically, we will have our server running in its own domain. In this case, it will be localhost colon port 5000. And as with our WebSocket application, our client is going to be running in its own domain, which is basically, we're opening it as a file. So as far as our server is concerned, running in localhost, that's a different domain. If they were both running in localhost, you wouldn't have an issue, but because they're running in different domains, that gives us a problem. And generally as a security measure, you do not want applications from different domains just being able to talk to each other ad hoc. And that's where CORS comes in, cross-origin resource sharing. It's basically a method that allows you to admit certain domains to talk to other domains, and that's all we're doing here. Now, you probably have a question, how did our WebSocket application work without doing any of this stuff? I will come on to that in a bit, but for now, we have to use it with SignalR, and we configure it in this way. So the main thing you need to configure is what origins do you want your server to allow in. So our server's running as localhost. What origins do we want to admit to connect? So that could be a domain URL or something of that nature. Now, you do that by specifying this with origins tag. Now, in here you would typically put HTTP, the name of the domain. Because we're running as a file, it took me a little while to find out what I should actually put in here. And it turns out you simply put a string called null, because when you look at the headers, the request headers from our client, which we can't do quite yet because we've not written it, but when we do, and if I remember, I'll show you the request headers with the origin value, and the origin value is null. I did try null, it didn't like that, so it does like null. Okay, so basically you're saying if you see any request from an origin of null, you can admit that through. Now, a word of warning, those request headers that specify the origin can be hacked or can be edited, so do not just rely on this to say that the application is authorized to use your service. You probably would want to add another layer of authentication on top of that. But for now, this is what we'll use, and we have to use it, because if we don't use this, if we don't admit it, then it won't work. The other thing, I'm just going to basically open the floodgate so you can see you get all these other options here. So I'm going to allow any header. I'm going to, it's getting a bit annoying, I'm going to allow any method. And finally, I'm going to allow any credentials. So what I've effectively done there is I've just essentially opened up the entire floodgates, which is not advisable, but just to get this working, that's what I've done. And the main thing really is we're admitting this origin of null, okay? So that allows our client basically to use our server. Cool, so that's that request delegate set up. And then the last thing we need to do, and then our server application is done, would you believe? We do app use SignalR, and in SignalR we create something called, well, I guess you'd call it an endpoint or a route point. I'm going to call it an endpoint. And using our lambda expression, that goes to curly brackets, endpoints. Actually, let's pluralize this because we may have more than one. And we're going to map our hub, okay? What hub are we going to map? We're going to map our chat hub. In here. And then what we can do also in SignalR, and we could actually do this in WebSockets as well, I didn't choose to do that, we can actually provide like a little specified URL on top of our base, in this instance, localhost URL. So this would mean you could have multiple hubs running at a different address. So you could think of maybe if you have different channels or different teams or even different organizations, they'd all have a different URL, and that's what we're specifying here. So we'll call it chat hub. Cool. So that's basically it. One semicolon to put in. So again, just to go back over what we've done, we've added our services that we require, and we require cross-origin resource sharing. We've set up our request delegate to be one of the first things we do in the request pipeline, and that's basically just admitting anything with a null origin in. And then finally, we're setting up our endpoint, which is effectively our chat hub. So quite straightforward, very readable, very simple, and that's basically our server app complete. So just before we move on to our client build, and while I remember, I did say, how did our WebSocket application work without using cores, which is a very valid question, and I asked that myself. I'm referring to the Microsoft documentation, and it actually makes sense based on what we know about WebSockets, that essentially they're very basic, they're very simple, very powerful, but simple. They don't provide a lot of anything else out the box like management or security. So basically out the box, if you're using pure WebSockets, they don't really challenge you for any kind of cross-origin violations. They just work. Okay, so that's why our WebSocket application just worked. So with SignalR, obviously, the guys who wrote that framework, they've built in this extra security checker validation that you must add cores to a SignalR application in order for it to work. Now, with WebSockets, you can actually still add cores to your request pipeline, and that's all good, but you don't have to. Okay, so that's why our WebSocket application just worked. And it's possibly, depending on your viewpoint, another reason, or a reason, not another reason, a reason why SignalR may be preferable to WebSockets. But again, depends upon your perspective, I suppose. Okay, so let's move on with our client build now. Okay, so we're going to move on to our SignalR chat client now. Because we've already created a WebSocket JavaScript client, there's a lot of the code, not most of it, a lot of the code is basically exactly the same. The HTML is pretty much exactly the same, and large sections of the JavaScript is exactly the same. So rather than type all that out again, which I'm sure you don't want to watch, and I certainly don't want to do, I'm going to use the C word, and I'm going to cut or copy and paste that code into our new SignalR project. Now what I've done is I've actually created like a template of the code we've already used. I've taken out some of the bits we don't need from the WebSocket client, and any new code I will be typing in. So you're not going to miss anything. Any new novel stuff related to SignalR, I'm going to type in. Anything you've seen before, I'm just going to copy and paste it in. Okay, so hopefully you're okay with that. So we'll leave our server project open. Let's just do a .NET run. just to make sure it's running okay. Looks like it's running okay. We'll leave that running actually. Now what we want to do is we want to create our SignalR client project. All I'm going to do is basically create a folder, and I'm just going to call it SignalR client. And then we'll just have a new window. And I don't like how this goes off the top of the screen. It's because I've got my screen magnified, so it looks a bit easy. It's easier for you guys to read on smaller devices. And we'll simply open that folder, SignalR client, make sure we open the right one. And we've got an empty, it's not really a project, but an empty folder. And we'll add a new file and we'll call it SignalR client.html. And this is something I don't really want to do, but I'm going to do it, is paste the code in. Actually, it's the right thing to do, because I'm sure you don't want to see me type all this stuff in. So all the HTML you will have seen before, and it is exactly the same, does not change. The only thing we're going to change is the word WebSocket to SignalR. That's all. So nothing too complex. Just so we don't, SignalR, I've totally spelled that wrong. I actually think I might be slightly dyslexic, SignalR, okay. And I am with numbers, I find it very difficult to read out long numbers. Like if you get like a phone number, I need it separated with spaces, otherwise I'm totally lost. So other than that, the HTML stays exactly the same. This section of JavaScript where we basically create JavaScript objects from our HTML elements stays exactly the same. Our first change comes here, and instead of using raw WebSockets, we're going to be using HTTP with SignalR. Ultimately, it will use WebSockets in the back end, but we connect in using HTTP. And then if you remember, when we created our endpoint in our server application here, we mapped our chat hub to an endpoint, we have to put this in, let's just copy that, in at the end of our URL. So they connect into our chat hub, okay? So fairly straightforward changes. I'll just go through what we've already got here just so you're comfortable. We've got our connect button on clicked event. We've just got updating the status and our addition to the comms log. We've got our close button on click event. That's got nothing in it at the moment. Same for our send button on click event. There's nothing in it, but there's this in it. I want to tab that in. We've got our entry to our comms log. This will error out, so let's just take that out just now. And we can add something in there later. Our HTML escape function remains exactly the same. That does not change. This function where we were looking for this con ID and we're kind of pulling that apart with the string that we're getting back. It's a very ugly function, and in fact we don't need it anymore, so let's take that out, it's gone. And our construct JSON payload, which is basically stringifying the message that we want to stay out, that stays exactly the same, so that stays as is. And then our final function that you've seen before is our update state function. This does change slightly. This is the WebSocket code that we've got here. I've not changed it, but we will go through in a minute and make the necessary changes to the switch statement so that we're reflecting UI changes accordingly. Okay, so before we touch any code in our SignalR client application, one of the things that you'll remember from the architecture diagram was that we rely upon a library file or an external JavaScript file called SignalR.js. So we need to include that and grab that for our project. Now, the tool that you use to do that is something called libman, stands for Library Manager. Fairly self-explanatory. It's a bit like NuGet. It just allows you to get client-side libraries and add them to your project. So first thing you want to do is check that you have it installed. So back over in our project, just make sure we're in the right directory. Yeah, we're in our client directory. If you just type libman -- version, if you have it installed, you'll get a version number coming back. If you don't have it installed, it will complain no such application or program file or something like that. So to install that, I'm going to break all my rules again, and I'm going to actually show you the string that you would type in. This is also on the blog, and I'll flash it up in larger text on the screen here when I come to editing the video, but you'll type in .NET tool install -g microsoft.web.librarymanager.cli, and that will install it for you. I don't need to do that because I already have it, so let's get rid of that. So the next thing you need to do is then tell libman I want to get the SignalR library files. So libman, I really should probably cut and paste this in as well, but I'll speed up the text, speed up the typing. So that should basically install this file, SignalR JS, into a file called folder called lib/signalr/dist/browser/ let's go away and run that. You can see something's happening up here. There you go, and we say installed library ASP.NET SignalR to lib/signalR. So in here we should have, yeah, we are, SignalR distribution browser SignalR JS, and it's just a JavaScript, rather large JavaScript file that we will want to include. So let's do that now. Let's include it in our application. So to include it, we simply include another script tag, and it's quite nice. It will correct you if you're a terrible typer like I am. And what I really love about Visual Studio Code is it will actually provide you with this kind of almost like IntelliSense drop-down folder structure. How beautiful is that? Isn't that wonderful? That's just, oh, beautiful, and it completes it for you. My goodness, that's rather magnificent. So what we might do, just to test it, is go to our client application folder, and we might just open this in, let's open it in Firefox. Now what I like to do usually is bring up the console, just to make sure there's no errors or warning, and it looks pretty good. We just do a refresh, it looks pretty good. If we do view source, and we click on this, it takes us there. Cool. So everything's set up correctly. It's all looking rather good. Let's just make this a bit smaller. Life is good. Okay, so we've included our SignalR JS file into our application. Now it's actually time to start coding up our application. So the first thing we really want to do with our SignalR client is create our hub. So in the WebSocket client that we've done previously, we had a WebSocket. We don't use that here in SignalR. We use what is called the hub connection to the hub. So that's the first thing we want to do in order to start using it. So variable, you call it anything you like. Let's call it hub connection. And you build a hub connection using something called a hub connection builder, which is something that's available through SignalR. So we access that through SignalR, and then hub connection builder. And we pass in a URL. No surprises what URL we're going to pass in. Yeah, we're going to pass in this, so let's just pass in our value here. And then we just chain that with a build. So fairly straightforward. We have this hub connection now that we are creating or building using our connection URL value. So we want to obviously open that connection now, and the place to do that is in our connect button click event. So you'll see this stuff here that's familiar from our previous application. We've just got an attempting to connect. We're then going to do something, which is what we're going to do with our hub connection object. So the way you connect to a hub is to use the hub connection object and then call start method on it. If it starts, then function, and we basically do something. So all we're really going to do upon connection is update our state. And we'll also write out to our comms log. So let's just copy this, copy it, cut it, and paste it in. And yeah, say that we have opened our connection. Fairly straightforward. Now, the one thing that's not going to work is, and one thing I did mention previously, is that our update state method will need a bit of updating before it will work. So let's jump down and do that now. So here we are, update state. Now the only thing that we really need to change, or there's a few things we need to change. This stuff here, these sub-functions of disable and enable all remain exactly the same. The first thing that you can see probably needs changing is we're referencing our old WebSocket socket. Instead of that, we're going to type in, if we don't have a hub connection, then we're just disabling everything. Then likewise down here, we don't have a socket ready state, we'll use hub connection state. Now the other thing that I'll just mention here, we've included our SignalR library here. Apologies, that's my phone going. We've included our SignalR library here, and I've tried a few other ways to kind of almost reference and include the SignalR library in this client file so that we get the IntelliSense dropdown. I've tried everything and I can't get it to work. So if you find how you can get that, if you can get that working, let me know, and I'd be very much grateful. But one of the manifestations of that is I can't really, or I can't figure out how to look at the hub connection state enumerations and use those. So instead, unfortunately, we're going to have to use magical strings, hard-coded strings, which I absolutely hate. And the only way I could get that was actually by going into the SignalR file and looking in the code there to get those connection states. So the first connection state, actually just undo what I changed there, was our previous WebSocket closed state. So instead of doing a case on that, it's simply disconnected. There is no such state called closing in SignalR, so we'll take that out. There isn't a connecting state, but there are, well actually sorry, there is a connecting state, but we have to reference it through a magic string. Connecting. And then there isn't really an open state, there is what they call a connected state. So let's change this to connected. Cool. And they don't have this either, so let's take that out. Let's just put unknown here for now. So that for me is a little bit of a work in progress that I would like to use proper enumerations here and get the IntelliSense working for the SignalR library. I can't seem to get it working, not sure why at this stage. Otherwise, it's fine, it shouldn't impact our code, just bear that in mind. Anyway, our update state method should now be working. I've been talking way too long. So we can test our on-click event because we're starting our hub, and assuming it starts, then we should get our updated state and something in our comms log. So I believe our server's running. Yeah, it's running. So if we go back over to our client, let's refresh it. Let's connect. So we get connected state, which is cool, and we got our connection opened, which is cool. So with that all working, let's move on to the rest of the functions that we have to change. So let's move on to our close button. That would probably make most sense. So in a very similar way as we did with our WebSocket, we're just going to check to see if we've actually got a hub connection object. Previously we were checking to see whether we had a WebSocket object. Do we have one, or do we not have one, should I say here, or if a hub connection state is not equivalent to connected, then we're just going to basically, we don't actually need those brackets, we're just going to alert and say something along the lines of hub not connected. Okay, cool. Assuming, however, actually, let's put some brackets in. Okay, cool. So assuming it is good, then we called our hub connection start method up here. We're going to call, any guesses what we're going to call? We're going to call our hub connection stop method. And yeah, so we're requesting to stop the connection. So let's, assuming that request is successful, the connection may not be stopped. We've merely requested it's been stopped. So what we'll put in here is we'll just do a console debug, and we'll just say requested stop on hub. And so what I mean by that is we've just said, listen, we want the connection to stop. It may not have stopped, we've merely requested it. So what we're going to do to mirror that is we're going to hook into the hub connection, if I can spell it correctly, on close event. And we can, if we need to access some event parameters, we're not going to actually use them, but it's nice to have them. And all we're going to do is update our state to just check to see whether, yes, indeed, the connection was stopped. And what I'm going to do is I'm going to copy this, paste it in here, and making sure that I change this from connected, because that could get very, very confusing to something like connection disconnected. Well, maybe we should use the language connection stopped. Okay. So let's test that. I think we have everything that we need to test connecting and stopping, starting and stopping. So let's go over here, let's refresh it. If we connect, we've got our connection opened, cool, and we close it. Oh, hub not connected. Okay. I think there's maybe an error in my code there, so we're getting the right messaging in our comms log and our correct state reflected, but we're getting the alert popping up. I think I must have made a mistake somewhere in here. Doesn't equal connected. Ah. It's a bit weird. Let's try that again, shall we? Just to prove that this is live coding and I'm not over editing. I mean, I do obviously edit a lot of stuff that you don't see, but I do try to solve things in real time. That's better. Okay, so we can connect, connection opened, connected state, close the socket, connections stopped. Okay, very good. Okay, so that's our connection, disconnection all sorted out. What we're going to do, before we come on to our other events, we are going to now introduce one of the methods or one of the functions that we referenced from our hub. So if we go back to our hub and you remember, when we get a connection event on connected async event in our hub, we say we've got a connection established and we have this connection ID. What we then do is we then call this method, receive con ID, on our client and pass back our con ID. Now at the moment we don't have this method in our SignalR client app. We're going to add that now. So when we connect, this should trigger and call that method back on our SignalR client to update our UI with the connection ID. So why don't we do that now? Why not? What else are we going to do? Okay, I'm going to have a cup of tea after I finish this section. That's what I'm going to do. But for now, let's introduce that function. So the way that you do that in SignalR, it's actually very cool. You'll type hub connection, obviously, and then on for a sort of generic event handler. That's what I call it. And then we type in, actually, let's make sure we type in the right name because it is case sensitive. Receive con ID here. Okay, so hub connection on the calling of this method, which we're now about to define. Function. And we're expecting a con ID to be passed in to that function. all we're going to do is update our UI element, con ID, in our HTML, and we're going to set it to con ID, which is the string that's already displayed, and by default it will say NA, and we'll display the con ID. Making sure we select the right one, con ID there, cool. Okay, now just before I go on, some of the documentation I read, it suggested that you can actually access the connection ID just from within the JavaScript. You don't actually need to do what I've done here and trigger a method from the hub to pass the con ID back. Doing a bit of research, I'm still a wee bit confused by that, and I couldn't actually get that working, referencing the con ID from within the JavaScript. But then I also came across a post by one of the contributors to SignalR, and he said that they deliberately have removed the ability to access the con ID from within the JavaScript because they don't want people doing that. What they want people to do is kind of cross-reference the con ID, connection ID, with the user's login ID and use that instead as a method of identification. Which is kind of fair enough, and that's kind of what I suggested we do with our WebSockets as well. You don't really want to be working with raw con IDs. It's not very user-friendly, it doesn't look very nice. But for the purposes of this demonstration, I'm quite happy to use the con ID, and so I'm kind of bypassing, I believe, what the SignalR team are suggesting you don't do. I'm just making you aware of that, but for all intents and purposes, we're just trying to route messages to endpoints, and I'm using the con ID to do that. I didn't want to build in this association layer between your user ID and the con ID. So that's my view on it. If you've got a different view, please drop me a line, put a message in the comments below, or drop me a line on the blog or whatever. Be interested in your views on that. So that's why we're doing this. We're actually kind of bypassing the SignalR team's wishes. So then all I want to do is just update our comms log, and you will excuse me, I'm just going to paste that code in. So comms log, connection ID received from the hub. This is very basic HTML. It's just going to be very boring if you watch me type that. And I don't want to bore you. So let's save that, and then once it's saved, we'll move back over to our client, refresh our client, and what we should get when we connect is we should get the con ID passed back. And indeed we do. So our connection is opened, we've got a connection ID received from the hub, and we have the connection ID there. All very good. We're on the final furlong. We're almost at the end of coding up our SignalR client. So all we've really got left to do, we've got two more methods that we need to complete. Now, the other one we'll do quite quickly is kind of the sibling of this one here, where we have our receive con ID event. We're passing back the con ID. And if you just pop back over to Hub, we did have one more, which was receive message. Okay, so basically on the invocation of that method on the client, we're just going to basically display the payload, the JSON payload in our comms log. It's that simple. It's not really that fancy, but it's just proving that we can receive that message. So once again, hub connection on, and this time we pass that method in. Let's just go back there and copy that in. On receive message. And in a very similar way, you're just going to define a function to handle it. Pass in the message. Okay. Now, all we're really going to do is just print that message out onto the screen. It's nothing really more fancy than that. So again, it's just very basic HTML updating our comms log. So rather than me typing it in, because you've seen it before, I'm just going to paste that in. So comms log under HTML, blah, blah, blah. We're escaping the message. Now, the only problem is with having done that, that's cool, but there is no way as yet to send messages from our client. We've got our button, our send message button, but as yet we don't actually have anything. It's not doing anything. So that's the last piece of our puzzle, if I can find it. So here it is. Here's our send button event, and we've got I already had this in here. It's basically just showing you the message that's going out from our client to the server. So what we now need to do is basically, when we click this button, what we need to do back over on our server is we need to actually invoke this message to trigger the routing mechanism out to the other clients. So let's do it. And once we've done that, do you know what? We're done. So all we're going to do is very similar, actually not similar, identical to what we did in our WebSocket client, and basically construct our JSON payload and put it in a message object, although it's basically a string. And then here's the bit of novelty that you've been hanging out for. On our hub connection, we're going to call this invoke method, and it's very similar to how it's basically the opposite of what's happening here. So our hub invokes these messages, whereas our client is going to invoke our send async method, if that makes sense. It should do. It's basically just opposite ends of the same thing. So my eyes are going cross now. Let's paste that in there. And all we send over is the message. And to be honest with you, it's that simple. So by calling this invoke method on our hub, we're basically going to trigger this message on our hub, and our hub is then going to run through its routing logic and then fire off that message to either all clients or a targeted client. It's really that simple. And then all I'm going to do again, oh, it's actually already there, isn't it? I don't need to copy it in. It's already there. I was just going to say we need to update our comms log, but that is already there. So that's all we actually needed to do on our send event. Create our message. In fact, I should have left that in from last time because it's identical. And then all we do is call the invoke method on our hub. Save. And with it saved, if we fire up our client, let's try it just with one client to begin with rather than getting overly complicated. So let's close our socket. Let's refresh our client. We'll connect in. We've got this ID. Now, if we just type in hello everyone, it should broadcast out to every client connected to our hub. We've only got one client connected to our hub, but you can see here from the client to the server, we're sending this payload, and because we're broadcasting, we have sent out, we've received that same message back from the hub. So it's kind of like your traditional echo type scenario. So what if I can find amongst my millions of drives where the client is, let's open it up. Let's open up another one. And let's test our broadcast again. Oh, you'd have to connect first. And then send. Cool. So again, we get the double messaging here on our sending client, but we get our inbound broadcast message from the hub to this client. So again, it's very similar to what you've already seen with the WebSocket stuff. I'm probably not going to, let me just put this one in here just to test it. If you put a recipient IND here and go hello from client 2, there you go. You get an inbound message from our client, and we get only the inbound message from that other client. So I can't believe it. We've got to the end of the coding. You'll be pleased to hear. So I don't know about you, I'm going to take a quick break. I'm going to have a cup of tea, and then I'm going to come back and I'm going to wrap it up for you. Well, that was epic, as I'm sure you will agree. Over 3 hours, edited down, in fact, to over 3 hours. That wasn't my intention, it's just the way things panned out. So, which is better, coming back to the whole point of the video, which is better, WebSockets or SignalR? Well, I'm sure as you probably realise it was a stupid question. It's not a fair question, and really the answer is, well, it depends, of course it depends. What I hope this video did give you though was enough information to make an informed decision about which one you would use in your projects. And ultimately it boils down to, do you want to build your own management layer, or do you want to use someone else's that they've already built for you, as in SignalR, or do you want to use pure WebSockets where you're going to have to build your own stuff around the edges of it? And that really is it. That boils down to that question. You're going to have to build a management layer anyway. Which one do you want to use? And it really depends on your situation. For me personally, I enjoy using both of them. I enjoy learning about both of them. It would depend on what project or what my situation was in terms of which one I would choose to use. At this point in time, I'm enjoying using WebSockets because it's operating at that lower level and I kind of like building up my own management layer around it. SignalR though is perfectly decent and I could totally see why somebody would choose to use that. And in fact, one of the things I didn't mention about SignalR is that if it can't use a WebSocket to establish a connection, it will fall back to, I think it's long polling. So it's very versatile and really powerful actually, and it could probably save you a lot of headaches if you're using it for a real world application. But again, that's entirely up to you. So anyway, I'm going to leave it there for now. I think I've been speaking more than enough, and I will see you again next time, where I hope you can join me for a much shortened, less lengthy video. But until then, thank you again, and I'll see you next time.